Hello info person, this is Anton, and in this video we're going to discuss yet another unusual discovery of a black hole that's currently very difficult to explain, and actually a black hole right here in the Milky Way galaxy, and specifically what seems to be the smallest black hole ever seen with a mass believed to be completely impossible. And that's of course based on our understanding of how black holes usually form. And so let's discuss this recent discovery of the object referred to as G3425, talk about why it's unusual, and also speculate about how it could have been created. But first, how exactly was this detected, and why is it that this is the first time we've ever seen this? So normally when it comes to smaller black holes, so not the ones in centers of various galaxies, we only see them when they start emitting a lot of light, usually by consuming matter from their partner, and by then producing very powerful X-rays. But in the last few years, ever since the launch of the Gaia telescope, researchers have also started to discover inactive or dormant black holes, usually in orbit around various stars, even though they're practically invisible. And the reason this is possible now is really because of all of the data collected by Gaia. The Gaia telescope is about to finish its fourth observation and release its fourth data, which means that we now have data for approximately 1.5 billion different sources, or approximately 1% of the entire Milky Way. And the data for each of these sources is extremely accurate. It shows us the exact motion, the precise light coming from each individual star, and thus allows us to calculate any deviations from the overall vector of velocity. And so a few years back, we had our first discovery, Gaia BH1, or Gaia Black Hole 1. First dormant black hole discovered by Gaia orbiting a distant star. And so within just a couple of years, 3 such black holes have been confirmed by Gaia, all dormant, all invisible, and all with somewhat unusual masses. And the latest one, Gaia BH3, seems to be one of the strangest ones. It essentially contains one of the largest stellar mass black holes ever found, 33 solar masses in mass. That's also kind of difficult to explain, but you can learn more about this in one of the videos in the description. And so because of these astrometry techniques, we now have a lot of data to discover a lot of these hidden giants. But just a few months after this discovery, researchers using Gaia data combined with the Large Sky Area Multi-Object Fiber Spectroscopic Telescope, or LAMOST for short, discovered something else super bizarre. By looking at deviations in orbit, and specifically looking at stars with radial velocity variations, and then combining this data with the Gaia telescope, they discovered one object that really stood out. This one star, that seemed to be a red giant, roughly around 5900 light-years away from planet Earth, seemed to orbit something invisible really close to it, but something that once again was not emitting any light. And not just X-ray light, any light. Suggesting that this could not have been some kind of a smaller, less visible star, and definitely not a neutron star, and not an active black hole. And because the motion of the star was very specific, based on the observations of this red giant, researchers were able to determine the exact mass of the invisible object. And it appeared to be 3.6 solar masses, which is really bizarre, because that's right in the middle of what we usually refer to as the mass gap, or basically a kind of a gap in masses of neutron stars and black holes where we don't actually know if anything can even exist. And that's because for the most massive neutron star, there is a mass limit referred to as the Oppenheimer limit. It's believed to be approximately 2.3 solar masses, but we know that certain magnetized neutron stars, especially the ones that spin super fast, can technically go up to about 2.9 solar masses for at least some time. But after this, they usually end up collapsing into black holes. Whereas for black holes formed from a supernova, and specifically a Type 2 supernova, all of the previous calculations, where they basically assumed some kind of an extreme star containing only helium core, the minimal possible mass for a black hole is 5 to maybe 7 solar masses. So here, through supernova, there's just no way to create this. Yet it was pretty clear that this was a very specific binary, an invisible object, and a star approximately 2.7 solar masses in an almost perfect circular orbit. Okay, so what exactly are we looking at, and if this is a black hole, how can it possibly exist? And one of the bigger mysteries here is actually in regards to that orbit. In many previous cases, all of these black holes and their stars would often contain elliptical orbits, implying some kind of a disturbance in the past, and this disturbance was always believed to be the result of initial supernova. So in essence, once the star explodes, and once it forms a black hole, the natal kick from the supernova would nudge the system just enough to produce elliptical orbits. And so with previous discoveries by Gaia, pretty much everything kind of made sense. Here though, it really doesn't. Circular orbits suggest that there was probably no supernova, or if there was one, it was extremely weak. Which once again brings us to that original question. How can this form and what exactly is this? And while most of this paper, by Song Wang and his team, is essentially dedicated to potential solutions, but none of them so far seem to be definitive or even make sense. For example, one of the propositions was that, well, maybe this is just super tiny stars or even binary stars. They're just exceptionally difficult to detect. But here, following an extremely accurate analysis from the Lamos telescope, they really found no light whatsoever. Even a tiny star would produce something, but not in this case. And so because of that circular orbit of 880 days, the overall conclusion from the study was that whatever is here, it's been stable and undisturbed for an extremely long time. Which doesn't really make sense when it comes to assumptions about black holes and specifically black hole binaries. These are not expected to be stable or undisturbed locations. On the other hand, scientists have also assumed that maybe this is a result of a capture. But once again, because of the orbit, that would be practically impossible. And so of all of the solutions they provide, only one so far kind of maybe makes sense. And here we have to assume that this used to be a triple system, and that black hole used to be two separate objects. And here let me introduce you to a slightly more unusual concept proposed by theoretical physicists a few decades back. Here we have super bizarre objects known as TZO or Thorne-Zitkow objects. And well, in a nutshell, these are stars inside stars. Or specifically, these are neutron stars inside red giants. A result of a binary system where a neutron star that existed before eventually got absorbed by a larger star and basically starts to reside inside of it, slowly consuming the core and everything within for up to 1 million years. And though at first this was just a hypothetical proposition, there are now a few candidates, including HV2112, that are possibly these types of objects. You can actually find the list of candidates in one of the links in the description. And so in essence, this would be a kind of a hybrid star that after a few 100,000 years would slowly consume the red giant from within, eventually becoming either a powerful long-lived pulsar, or if enough mass was consumed, would collapse into a black hole. And previous studies have actually assumed that up to 200 such objects should currently exist in the Milky Way. But we've never really seen the end product. And while the only explanation that potentially makes sense for this star is that maybe this is what we're looking at. A TZO object formed from a previous neutron star colliding with another red giant, eventually consuming it from within and eventually becoming a slightly bigger black hole right in that mass gap. And here, this would explain why we're seeing circular orbits, no disturbance whatsoever, and more importantly, how this black hole is even possible. But naturally, this is still just a speculation, and a lot more evidence is needed to see if this is true. If true though, this would be the first such object discovered ever, and would definitively confirm the assumptions about TZOs. But naturally, the much more important and bigger solution now would involve additional observations and of course confirmations. And that's because, like in previous studies, there might be some mistakes here, specifically in regards to distances. And that actually happened before. A separate astrometric detection of a black hole from a few years back was also very bizarre and somewhat unusual, but turned out to be just a distance measurement error. Or technically not an error, but just an assumption based on the way we get data and the way astrometry works. And so there's actually still a chance that maybe the distances here are kind of incorrect, and maybe this is just a normal black hole much farther away. But at least for now, this is still a super exciting discovery, and a discovery that, if confirmed, would basically suggest that hundreds of such objects must exist in the Milky Way, and will most likely be seeing more of them in the near future. Hello InfoPerson, this is Anton, and well, looks like, as the title of the video suggests, there seems to be some kind of a super powerful source of cosmic rays right in the middle of the Milky Way, but nobody knows right now what exactly it is. And yeah, it's not the central black hole. And so let's talk about this new discovery in a little bit more detail, but let's actually start with what's happening and what we know so far. And the story here begins in 1912. And here the story starts with Victor Hess, an Austrian-American physicist who back in 1912, by measuring radiation at the sea level compared to the altitude of 5.3 kilometers, completely by accident discovered that something seems to be hitting planet Earth from all over the place. Here's that famous picture of him inside the balloon where he made this discovery. And well, in 1936, he won the Nobel Prize in Physics. He basically discovered cosmic rays, extremely fast-moving particles such as hydrogen, helium, and in some cases some other atoms, that seem to come from all over the place, pretty much at all times, but then by striking the upper atmosphere, end up producing what's known as the cosmic ray air shower, which usually results in a cascade of various particles and various high-energy photons, which we then detect as radiation. Fun fact, a lot of my older video games, such as the ones I used on Nintendo DS, have been basically permanently damaged as a result of cosmic rays striking them for approximately 20 years now. As a matter of fact, when it comes to various types of media, and of course computers, damage from cosmic rays is a lot more common than most people think. But that's beside the point. The point is that he discovered cosmic rays, and this was just the start. And today we know that there are so many different sources of these unusual particles, but usually it depends on the energy. Some of the lower energy cosmic rays usually come from the sun, but the vast majority of sources seem to be outside of the solar system and generally seem to come from either various supernova remnants or, more often, very distant supermassive black holes that seem to be shooting those particles at us at all times. We usually refer to these as galactic cosmic rays. And while the majority of them are basically just hydrogen, while the 12% are helium nuclei, and a very small part are extremely heavy atoms, usually iron. But in order to achieve these velocities and to basically become so highly energetic, they have to be accelerated by something extremely powerful and very often for a very long time. Here's one of the animations made by NASA that kind of shows us how sound this might work. And so sometimes by traveling through galactic magnetic fields, these particles will actually travel for a very long time before arriving to planet Earth. But in many other cases, we also detect the gamma rays from the original source and thus can deduce where some of these particles are coming from. And here's one of the ways supernova usually produce these. Here basically by crossing the shock wave and by acquiring more and more energy, a lot of these particles reach almost the speed of light, escaping in the process. And so many of these particles actually travel to us for millions of years and do get accelerated over and over by various magnetic fields. But as they travel through some of the interstellar medium, and specifically some of the gas, they also interact with this gas, emitting gamma rays, allowing us to track their motion. And the stronger the interaction, or I guess the more energy these particles have, the higher gamma ray energy they produce. And so since once again gamma rays travel in a straight line, we can generally find unusual sources somewhere out there. And in many cases, when there's a source of cosmic rays and some kind of a thick gas cloud nearby, we'll actually usually detect a lot of these very powerful rays coming from this cloud as a result of the interaction. And so these high energy gamma rays reaching the planet end up interacting with the molecules in the upper atmosphere and once again producing a type of a secondary shower. And here scientists discovered a brilliant technique on how to detect them. It basically involves massive tanks of water that also contain various photodetectors that can actually detect what's known as Cherenkov radiation. When various particles pass through this water, they will basically make water glow just a little bit. This is a result of these particles traveling at a much higher speed than they should be traveling inside water. Here's a famous example from a typical nuclear reactor. And so many of these detectors essentially work in a very similar way, except here we can even trace the gamma rays to exact sources in the night skies. And so detectors like this, high-altitude water Cherenkov observatory, are perfect for these detections. But here they specialize in extremely high-energy detections, specifically something we refer to as tevatrons, or tera-electron-volt gamma rays, essentially some of the highest energy gamma rays produced in the Milky Way and technically the universe. But in the last few years, researchers started to discover something else, pevatrons, or peta-electron-volt. And that's a completely new level, something that we cannot even produce right here on Earth. And in the last few years, approximately 100 sources of these extremely high-energy gamma rays have been identified across the night skies. And though most of them are probably distant central black holes, researchers are more interested in things that are inside our galaxy. And although tevatrons have been discovered in the Milky Way before, it was not until recently that scientists discovered pivatrons. And in this case, coming from sources we never really expected. For example, a few of them seem to be supernova remnants, a couple seem to be pulsar wind nebula, and some seem to have mysterious sources. But out of approximately 300 known supernova remnants, only a few of them have been discovered to have these super high energies. And one was actually really surprising. This was a discovery of a strange supernova remnant, G106.3 plus 2.7, that seems to be 2600 light years away from us and does contain a really bright pulsar. And here this was definitively confirmed to be a pivatron source that absolutely nobody expected. And so here this was a confirmation that supernova remnants and pulsars seem to indeed be able to produce them, but obviously through techniques or mechanisms we don't understand. But there was a bit of a question. Was there something similar near the center of the galaxy, and specifically, could Sagittarius, a star's supermassive black hole, have produced them sometimes in the past? And so that's essentially what the researchers wanted to discover by conducting additional studies. And that's because previous studies have actually suggested that there was a pivatron somewhere within approximately 30 light years from the galactic center, and something that emitted many of these powerful particles for at least 1,000 years. But obviously nobody knew what it was or how it was produced. So maybe there was something else besides supernova remnants or beside pulsars located in this region. And well, the point of this study by Albert and his team was to essentially see if there's really anything there or if it was just some kind of a mistaken observation. And so here, by using 7 years of data from HAWK, or basically these water tanks, and by analyzing over 100 gamma ray events, all of them containing very high energies, they definitively confirmed that there was indeed something in the center of the galaxy producing ridiculously powerful particles, and specifically producing pivatrons, the highest energy particles possible. And as these pivatrons travel and collide with a lot of gas nearby, they obviously release super powerful gamma rays, which is what we actually observe from the planet. And so they decided to see if they can identify this source or find out what it is. And they focused on some of the most well-known sources in the center. For example, one of them, the galactic center radio arc, is famous for producing powerful emissions. It's very close to the center and has been previously suggested as a potential source. The other source was obviously Sagittarius, a star black hole. The location we expect to produce a lot of energy at all times. But turns out that neither one of these sources explained what was being detected. Even when gamma rays from these two sources were extracted, there was still an unusual overabundance of extremely powerful gamma rays coming from somewhere in this region. And it was from a point-like source they now refer to as HAWK J1746-2856, something that's able to produce pivatrons, but what exactly it is, well, that's where the mystery starts. Because this study basically excludes all known sources, at the moment nobody knows what these ultra-high energy emissions are being produced by. But this study definitively confirms the pivatron source that seems to generate these gamma rays as these extremely powerful cosmic rays interact with dense gas extremely close to the galactic center. And so it's only the next generation experiments and next generation detectors that might be able to pinpoint exactly where this is coming from. For example, the Cherenkov telescope array or the Southern Wide Field Gamma Ray Observatory might be able to see this, but we just don't have the data yet. And so in essence, this study definitively confirms there is something ridiculously powerful in the galactic center, and it's not the central black hole. Today, I wanted to discuss a somewhat intriguing discovery of a gravitational wave that suggests a collision between a somewhat unusual object and a neutron star. A detection that was made back in 2023, but that was finally analyzed and released in a scientific study that, as always, you can find in the description below. And though one of the objects here seems to be a typical neutron star, the second object seems to be really strange. It falls into what's known as the mass gap, representing a mass of certain objects that at first scientists thought could not exist, but now that several have been discovered, represent objects that we currently cannot explain, or essentially we have no idea how they formed, or even what they possibly are. And so, hello wonderful person, this is Anton. Let's discuss this discovery and the study in a little bit more detail, focusing on what we think this probably is and why this might be kind of important. But I guess first, a quick reminder of how all of this works and how all of this is discovered. So now, after a few years of detections, we know that many different dense objects, as they orbit each other, tend to produce certain gravitational waves. Waves of space-time itself that, though invisible to us, can be detected if you build a machine large enough to have two lasers intersecting and producing a kind of an interference. And if something nudges them just a little bit, they'll actually start producing interference patterns detectable by precise measurements here on Earth. And because each of these lasers is approximately 4 kilometers long, they're able to detect vibrations whose wavelengths are either similar or shorter than that. And though these vibrations could be technically formed by, for example, someone jumping next to them and essentially shaking the planet, since we have at least 4 of these devices in 4 separate locations, 2 in the US, 1 in Japan, and 1 in Italy, by having the same detection at the same time from several locations, we can only make one conclusion. It must have come from outer space. And the only thing that can actually do this is if the Earth itself starts to basically oscillate and contract and expand as these space-time waves pass through it. In theory, it would kind of look like this, but this is dramatically exaggerated. These waves can only move our planet by something similar in size to a typical atom. But today we know that this is definitely something that happens, and it even happens pretty much at all times. There are different types of wavelengths, and they all seem to come from different sources. But the ones LIGO, Virgo, and Karga facilities can discover are usually coming from smaller black holes, or neutron stars. Various dense objects on a collision course whose orbits shrink because of interactions through gravitational waves until they finally merge into a single object. And so in the last few years, a lot of different objects have been discovered on a collision course, which sound them sort of unusual. You can learn about some of them in the description below. But this time, once again, we have something somewhat mysterious, something very difficult to explain. It is once again a merger, and a merger producing extremely specific gravitational waves, but both objects here are relatively small. One of them seems to have a mass of a neutron star, anywhere from 1.2 to maybe 2 solar masses, so not actually that massive, but definitely a compact object. But the second object was a little bit strange. It was about 2.5 to maybe 4.5 solar masses, and that's where the mystery kind of starts. This is literally in the middle of the mass gap. Too massive to be a neutron star, and too small to be a typical black hole. And to be more specific, recent studies have actually calculated that the most massive neutron star you can possibly have is about 2.3 solar masses, whereas the least massive black hole produced through a supernova is usually at least 5 solar masses. Yet here we have an object right in the middle of that. Extremely unlikely to be a neutron star, even if it's spinning really fast, and unlikely to be a black hole produced by a supernova, at least not according to modern physics. And all of this relatively far away, 650 million light-years away from planet Earth. But this detection was not super surprising, because technically it's not the first time. The one discovered back in 2019 was also somewhat unusual and also possibly in the mass gap. Here this object was about 2.5 to maybe 2.7 solar masses, so possibly something very similar. And that of course implies that these collisions seem to be not rare at all. Whatever this is, it seems to be a type of a new object. Although in this case, it could still be a neutron star if it was spinning really fast. But that's maybe beside the point. The point is that these objects seem to be real. Likewise, there's another mass gap at a much larger mass, specifically in hundreds of solar masses. And that same year, in 2019, the researchers found 2 separate black holes, both in that massive mass gap, colliding and creating something even more massive. In the process releasing approximately 9 solar masses in pure energy, basically making that detection the most powerful ever observed. Although that collision was unusual and even more extreme for several other reasons. You can learn more about this in one of the videos in the description. But the obvious question in this case, in this detection is, so what exactly is this other object? And if it is a black hole, where exactly did it come from? With one immediate study coming out not so long ago, suggesting that this is maybe a primordial black hole. A black hole that was basically born in the beginning of the universe during the inflation period, where a lot of energy over densities suddenly combined into tiny black holes with different types of masses. And if this is a primordial black hole, that's actually a really big discovery. It would imply that these black holes exist everywhere, and they could potentially explain dark matter, and even various anomalies we observe right here in the solar system. As you might remember, there was even a study trying to explain the effects from Planet 9 as a potential primordial black hole right here in the solar system, somewhere on the outskirts. And so confirming an existence of primordial black holes would be a huge deal. But right now this is not a confirmation because it could have been produced in other ways. It actually could have been a result of a merger of two separate neutron stars before this recent collision with the third one. Or in other words, if we have two neutron stars and they collide into a larger object, they will almost always form a black hole. This is due to a very specific critical gravitational mass known as the Oppenheimer limit, and that's around 2.3 solar masses. Above this, everything turns into a black hole. And so following this, once it already became a smaller black hole, a third neutron star, possibly in the same orbit, or maybe even from somewhere else, formed another collision and a much larger object in the process. And though some neutron star collisions can actually produce a supermassive neutron star, at least for some time, before it stops spinning and collapses into a black hole, in this case the final mass was already too great, and so they must have become a black hole almost right away, while also very likely resulting in a typical kilonova, the explosion that produces all of the heavier elements in the universe. You can learn more about this in one of the videos in the description. But because of this detection, we now know that this particular mass gap maybe is not a mass gap after all, or basically is a mass gap in terms of our theories. We just don't have an explanation for this yet, but because two such objects have already been discovered, it means that these are pretty common. Although since in this case no physical explosion was detected from this region, the collision must have been very sudden, with the neutron star basically just getting swallowed almost completely. But luckily for us, we'll have even more discoveries, possibly in the next few years. And that's because by 2025, another facility is coming online, this time in India, that's going to be joining the collaboration. And by having 5 such facilities in 5 spots on the entire planet, it becomes extremely easy to triangulate the location for each of these events. And so we're probably going to be detecting dozens of these pretty much every month, with more mysteries uncovered in the process, and more importantly, a much larger facility that's actually going to be in space, known as LISA, has now been approved for construction as well, and might become operational possibly in the next decade. And this one will change everything. You will be able to detect really massive gravitational waves and uncover a tremendous amount of mysteries that we cannot even imagine yet. But when it comes to gravitational waves and mysteries, there are definitely quite a lot. Today I wanted to once again discuss a somewhat bizarre phenomenon discovered just a couple of years ago. A phenomenon that involved the most energetic, transient astronomical event visible in optical light, or essentially an explosion that we can actually see with our own eyes, but in this case an explosion that lasted for at least 3 years, or ever since it was discovered. And the event so bizarre and so strange that it basically became known as Scary Barbie. But for reasons I should probably explain first. This was discovered by the famous ZTF or Zwicky Transient Facility, an automated telescope that's able to directly detect various changes in brightness somewhere out there in the night skies. And in this case, the word transient refers to the sudden change in brightness somewhere out there. And so basically here it's looking for things like supernova. But on April 13th of 2021, it once again detected something, but this time something very strange. Because this is an automated facility, it usually names things in a very specific but somewhat random way, and so this time, this event received the name that you see right here. And because in this case the letters resembled Barbie, and also because it was somewhat unusual and somewhat bizarre, over time it became known as Scary Barbie. And to date, it seemed to be one of the most powerful optical events ever discovered. Now, not the most powerful explosion, that record belongs to something else we discussed recently, the gamma ray burst that we've discussed right there, in the description below, but even in this case, the amount of energy emitted was really huge, especially because it's been doing this for practically 3 years now. But the reason it's actually known as Scary Barbie and not just Barbie is really because of the mystery of its origin. Nobody has any idea what's actually happening here or what created this. Because normally, when we see some kind of an event like this, we expect this to be some kind of a star or some kind of a massive object being shredded by the supermassive black hole. So basically a TDE, tidal disruption event. But if it's a supermassive black hole, we expect it to be in the middle of a galaxy. Yet despite various observations using some of the most powerful telescopes, pretty much nothing has been discovered in this region so far. There does not seem to be a host galaxy, thus making this a super intriguing and somewhat unusual discovery. A discovery of an explosion, a very powerful explosion, but that seems to be happening right in the middle of empty space. But moreover, unlike other TDEs or other disruption events, here it has not diminished in brightness almost at all, and ever since it started brightening years ago, it sort of remained the same. And so the question was, so okay, what's happening here? What can this possibly be? And is it aliens? It's not aliens. But yeah, the question is really, so what's up here? What is going on, and what can possibly create such a powerful explosion? Well, right now, a quasar or any kind of an AGN or active galactic nucleus is pretty much out of the question. It would have been detected a long time ago. As a matter of fact, a lot of similar very powerful emissions have been detected before, such as the one you see right here in a galaxy MS0735.6. This is technically a galactic cluster, and it's also producing very bright and very stable optical emissions, but here there is a galaxy in the center and a lot of galaxies around it. And so in that sense, this is definitely maybe similar, but not the same. Moreover, the spectral line features that can usually tell us about the elemental composition and even the origins of these events seem to be extremely different from a typical TDE. And so basically it looks very different from your traditional supermassive black hole shredding a star. For example, here we don't actually see any neon, any oxygen, or specific types of nitrogen or helium, something that's expected from certain TDEs and certain active galactic nuclei. And moreover, in 14 months of observations, the spectra did not change at all, and that's also very strange for a typical TDE. Nevertheless, we still have some explanations and some potential new discoveries that you can learn more about in some of the recent studies in the description. For example, when it comes to the missing galaxy, because this is actually pretty far away from us, the redshift of 0.99, or approximately 8 billion light-years away from us, it has been suggested that we're just not seeing the galaxy, because it's relatively small in size, and also because it's possibly hidden by a lot of dust, and would thus be below the detection limit for a lot of modern telescope surveys. So basically here, if the galaxy is enshrouded by a lot of dust, it would be somewhat difficult to detect, but could also maybe explain why we're observing so many optical emissions. If there's a powerful black hole in the middle, it would make a lot of gas around it extremely bright in certain frequencies. On top of this, in one of the most recent studies you can find in the description, researchers wanted to discover if more similar events were discovered somewhere else in some of the older data, with their initial search returning 59 events, but only 7 of them ended up being very similar to the scary Barbie, and they now refer to them as ANTs, ambiguous nuclear transients. Or I guess, for the lack of better words, strange explosions that basically currently make no sense. And in total, 10 such ANTs have been discovered to date, representing very bright optical flares that can usually last for 2 or more years, in contrast to a typical tidal disruption event. A typical TDE usually only lasts for 100 days. Likewise, in most of these cases, these ANTs resemble some kind of a very hot object, approximately 10,000 Kelvin in temperature, with very powerful X-ray emissions, essentially resembling some kind of a very hot, very bright star, except that they're not stars and seem to be visible from billions of light-years away. But pretty much all of them, except for maybe one, seem to also display an extremely powerful infrared flare, suggesting something really hot around them. And here researchers believe that it's most likely from some kind of a dust echo, or basically a very large dust cloud around something that seems to illuminate this dust, which then starts to glow in infrared. And in that sense, it basically suggests that it's most likely some kind of a supermassive black hole once again. But possibly supermassive black holes that seem to be located in either bizarre galaxies or possibly in extremely small galaxies with practically no stars. with the actual explosion or the brightening event most likely being the result of a very powerful accretion disk around these black holes. But exactly what's causing the accretion don't currently agree. Some still believe that it's possibly just a very strange version of a tidal disruption event. For example, for that scary Barbie, they think it's maybe some kind of a very massive star, approximately 14 solar masses, being shredded by a supermassive black hole that's 170 million solar masses in mass. But because in this case this particular black hole seems to be very massive, yet it doesn't seem to contain any galaxy around it, a lot of this currently makes no sense. While other researchers think it's something else. They actually suggest a really huge gas cloud, possibly thousands of solar masses in mass, interacting with a massive black hole that produces these long-term emissions. Although in this case, the inferred mass of the black hole is also once again at least 100 million solar masses, possibly even more massive. And that's just based on the brightness visible from 8 billion light years away. And so once again, even this explanation does not really make a lot of sense. If this is a massive black hole, how come we're actually not seeing anything around it? And why does this massive black hole appear so different from any other black hole discovered so far? And so in that sense, there are still obviously a lot of unexplained questions. But I guess the most important discovery coming out of these recent papers is just the fact that the scientists found more. More of these very unusual, unexplained, transient phenomena that appear as very bright flashes that don't seem to change much for years and seem to be very bright in optical emissions, or basically easily visible with a relatively powerful telescope. As a matter of fact, one of these events is already known to have lasted at least twice as long as Scary Barbie. The event known as ZTF-19 AAMRJAR. I guess armjar or something. But basically overall, this is still a bit of a mystery. A mystery of these unusual, very bright optical events that, though similar to a typical TDE, seem to be very unique and very peculiar. As a matter of fact, they are so peculiar that there's just not much else to say about them because we don't really know what's going on here. And if you watch that older video from just over a year ago that you can find in the description that describes the discovery of this event, unfortunately I've not actually added much more information here because we haven't learned much about these events since then. And so in that sense, this is just going to remain a mystery, like so many other transient events that even now have no explanation. But of the ones that really make no sense, this one is definitely somewhere on top. I mean, just the fact that even now nobody has actually found any kind of a galaxy here is definitely very surprising. And so if there is some kind of a black hole here, and it's like really massive, it seems to be basically a rogue black hole, just traveling by itself and suddenly interacting with something, maybe a star, maybe a massive gas cloud, which suddenly made this black hole extremely easily visible from very far away. But if this is a rogue black hole with hundreds of millions of solar masses in mass, the question is, where did it come from? And so I guess we're just going to leave it at that. It still remains a mystery, there are still not a lot of questions that have been answered, but we now know of 10 such events. And so whether this is a tidal disruption event of some kind of a massive star, or possibly a disruption of some kind of a massive cloud, we're not going to know until future discoveries and future observations. And let's discuss the famous wow signal once again. But first, just a little bit of a background so that we're all on the same page. And it all started sometimes after the Second World War, when the radio astronomy really started to pick up. Back then, a lot of astronomers started to propose that, hypothetically, if there was some kind of an alien civilization out there, and it really wanted to announce its presence, or possibly communicate with someone else, it would very likely rely on the so-called hydrogen line, the frequency of 1.421 MHz, created by the transition of neutral hydrogen when it changes its energy state, in the process releasing an extremely specific frequency of light. The light would wavelength of 21 centimeters, and the light that can technically penetrate everything in the universe, easily moving through all of the dust in the universe without being blocked by anything, and in some sense, visible from everywhere all at once. And though naturally this is also created by pretty much most of the hydrogen clouds out there, if someone were to make these particular emissions appear artificial, or basically modulate them in such a way that they definitely appeared as they were produced by intelligence, in some sense all of this would produce a perfect way to not just announce your presence to everyone out there, but obviously also communicate over long distances. And so back in 1959, an Italian physicist, Giuseppe Cocoon, who you see in this image from 1967, along with the American Philip Morrison, proposed searching for extraterrestrial intelligence using this 21 centimeter hydrogen line. And essentially based on the assumption that any kind of extraterrestrial intelligence might be basically doing the same, mapping the universe using the hydrogen line, and would thus maybe decide to announce itself using this very specific frequency. And so based on these early principles and these early assumptions, radio astronomers started to basically look around the night skies trying to find something. And approximately 2 decades later, while working on the Ohio State University Big Ear Radio Telescope, Jerry Eman, who you see right here, detected an unusual signal in that frequency that lasted for 72 seconds and was coming from the constellation of Sagittarius. And because this was such a surprising discovery, the astronomer marked it as WOW, which eventually led to this being known as the WOW signal that remained a mystery for several decades. And because of its unusual properties, this was assumed to be maybe coming from extraterrestrial intelligence somewhere out there, with the value itself being extremely close to the value of the hydrogen line, but much stronger than anyone expected. And as a result, several follow-ups tried to rediscover the source of the signal or possibly hear it again, with SETI also conducting several follow-ups, including potential technosignature search, trying to see if they could hear something else. But years and years after, still nothing. No technosignatures, no additional signals coming from this location, and more importantly, even Jerry Eman, who discovered this, mentioned that we should have heard it again if this was coming from an alien species. And so he even proposed that maybe this was actually coming from Earth and was just basically a reflection from some kind of a satellite out there. But that was extremely unlikely, just because of the chances of that happening, and because back then there were just not a lot of satellites to reflect from. And so naturally, so many different explanations have been proposed over the years, with pretty much all of them suggesting that this was a natural phenomenon. But here, before we tackle the best one, let me actually tell you a little bit more about the signal, just so that you understand what we're looking at. So first, the letters and the numbers. This is not an actual message, and instead represent a signal strength denoted by numbers and then letters, with U in this case representing the highest possible signal-to-noise ratio. And so in that sense, this just tells us that this was an extremely strong signal. But more importantly, if graphed, it looks like this. You have a signal becoming stronger and stronger for approximately 36 seconds, which then peaks and starts to diminish for the next 36 seconds. And that signal had no modulation and no additional information in it. It basically resembled a kind of extremely strong beam in that frequency of 1.4 GHz. But timing here is also extremely important, because this actually shows us something else. Because it was exactly 72 seconds, this actually showed us that this was the result of the Earth's rotation, or basically that it was extraterrestrial and was at first coming into view for 36 seconds, then peaked, and then started to move away from us for the next 36 seconds, with the source itself very likely being extremely far from the planet. But because there was no modulation, and this appeared to be some kind of a continuous wave, the main reason the signal was so exciting is really because we've just never seen anything like this before. It was the first such signal ever found, but in reality it really had all of the signs of some kind of a natural phenomenon. A phenomenon coming from that constellation of Sagittarius, and possibly caused by something involving hydrogen. Nevertheless, for many decades, a lot of scientists try to see if we can actually maybe find the source of this, or possibly find technosignatures coming from this location. In the last 5 years, there were a few papers that first estimated where this possibly came from, and then even tried to find individual stars that might contain some kind of a planet where the signal could have originated. Obviously in this case, assuming that this was from some kind of a civilization. But because the signal has never been detected again, and because once again it just appeared a little bit too natural and not artificial enough, most scientists did not think this was aliens and actually proposed quite a lot of additional explanations. For example, apparently, according to Antonio Paris, one of the astronomers in Florida, around this time there were a couple of comets in the same regions of the night skies. And he actually proposed that maybe the hydrogen cloud surrounding these comets could have produced some kind of an effect. But most astronomers actually don't think it's possible, and so this particular hypothesis, despite being interesting, was rejected pretty quickly. And then we have this new proposition, the proposition from August of 2024, that right now doesn't just make sense, it makes a lot of sense, and might even lead us to some other discoveries involving other mysteries such as FRBs or fast radio bursts. And so let's talk about this recent paper that was just released that potentially solves the wow signal once and for all. Now, the lead author here is Abel Mendez, who is pretty known on his work in Arecibo Observatory, but also for developing the famous Earth Similarity Index that's usually used in describing various planets and comparing them to planet Earth. And so for the past 7 or so years, Mendez and his team were working on analyzing radio data coming from various regions containing famous red dwarf stars with potentially habitable planets. And so here they were looking at planets in systems like TRAPPIST-1, trying to discover any potential radio frequencies between 1 and 10 GHz. And this was based on some of the older observations from Arecibo, but also from other observatories as well, and they had quite a lot of data collected. But while observing these stars and obviously looking for signals coming from their planets, they started to discover something entirely different. They started to discover a bunch of bizarre signals around various celestial objects that surprisingly resembled the wow signal way too much. And here this wasn't just 1 or 2, it was a lot all over the place, with a lot of recent observations basically resembling wow signal, just not as powerful, but in an extremely similar narrow band and with a very similar profile. And naturally, the first assumption here is that, okay, I guess there are aliens everywhere trying to communicate. The more realistic explanation is that these are actually natural phenomena formed by something very specific. Here by focusing on the Teegarden star, mostly because it contained the longest drift scan so far, they observed various signals consistent with something produced by cold hydrogen clouds. But here these clouds were suddenly brightened by an extremely powerful transient, or by possibly some kind of a stellar emission that very likely lasted for just a brief moment, but was powerful enough to suddenly make these clouds extremely bright, emitting a lot of radio light in the process. Specifically emitting what we usually refer to as a maser, or I guess for the lack of better words, a microwave laser. A well-known astrophysical phenomenon that's usually present around various clouds. Here's one of the more famous examples in the Jellyfish Nebula. And so these natural phenomena usually occur in various microwave or radio frequencies when something very powerful excites a molecular cloud, making it emit tremendous energies. Which means that something extremely powerful must have happened in the vicinity, causing these hydrogen clouds to start emitting these masers visible all the way from planet Earth. And though we obviously have no idea what exactly was this transient and what caused these clouds to appear this way, the researchers in the study believed that it was possibly some kind of a magnetar or a similar powerful object able to create very powerful emissions very suddenly. And so in essence, this schematic right here kind of explains what they think might have happened. Some kind of a powerful source hit the hydrogen cloud, which was then visible from planet Earth. And based on the observations of hydrogen clouds in the vicinity of these signals, this does seem to be like the more likely explanation right now. But no observations of the actual source of the transient, so basically we don't actually know if this was a magnetar or something entirely different. But intriguingly, if they're correct, and right now the evidence is pretty strong, it essentially then suggests that the wow signal was just a very unusual example of some kind of a rare astronomical event involving a hydrogen line maser flare, and possibly even the first one ever seen, but in this case also extremely powerful and possibly caused by some kind of a very powerful transient. And so now the obvious question becomes, so what? If this was a magnetar and if it was able to create these powerful radio emissions by shining at this hydrogen cloud, this could provide important answers for another mystery, the famous FRBs or fast radio bursts that to date still don't have a good explanation but have always believed to be caused by magnetars, possibly involving some kind of a cloud or some kind of a pulsar nebula. And because similar clouds do actually appear in the vicinity of the famous magnetar that produced FRBs right here in the Milky Way, all of this could potentially have extremely similar origins. But that's assuming that it was caused by a magnetar. Right now, as far as I know, no magnetars have been discovered anywhere in the vicinity, and so we don't really know what caused these clouds to become so bright. But since astrophysical masers are usually exceptionally rare, to astrophysicists this is going to be a super exciting discovery. To date, one of the first discovered and possibly one of the best known masers out there is the one coming from the star MWC 349. And in this case, it seems to be caused by some kind of a nebula around the star, or possibly even coming from the star's disk. And so by discovering so many masers out there, with all of them basically resembling the famous wow signal, in essence kind of resolves one mystery, the mystery of the wow signal itself, but creates a new mystery, the mystery of their origin and what's causing so much energy to be released to suddenly make these clouds so bright. Naturally not something we're going to be answering yet, but I'm sure in the next few years, with additional observations and additional studies, we'll possibly have new answers and new resolutions. Until then though, well, it looks like the wow signal is no longer as mysterious as it used to be. And also, unfortunately, it most likely did not come from some kind of a extraterrestrial intelligence. But it still seems to be some kind of a really interesting mystery and some kind of an unusual natural phenomenon that we currently do not understand. And once we do, we'll come back and talk more about this in some of the future videos. By observing the universe, we often find a lot of different locations containing a lot of different spherical structures. And in most cases, these spherical objects, or these expanding objects, are the result of some kind of a major event, such as, for example, a supernova or some other explosion in the center. Although it doesn't have to be an explosion, like in this case. This is just a planetary nebula, or basically a result of an aging star releasing a huge amount of gas that forms multiple spherical shells around it. And then at some point, when it becomes powerful enough, it starts to illuminate these shells, producing these beautiful reflections you see right here. And so normally when astronomers discover some kind of a spherical shape out there, the instant assumption is that right in the middle, there's gotta be something really powerful emitting everything. But then, approximately 5 years ago, from when I'm making this video, back in 2019, completely by accident, radio astronomers discovered these structures. Structures that are once again spherical in shape, but something we've never seen before. And interestingly enough, only some of them contain something in the center. Surprisingly, that something was usually some kind of a galaxy. But not all of them had this, and approximately half of them still remain kind of mysterious. And while today these objects are referred to as ORCs, odd radio circles. As the name suggests, they're strange, they seem to be only visible in radio light, and they're kind of circular. And well, hello wonderful person, this is Anton. Today we're going to discuss additional discoveries and additional new mysteries about these objects, despite the fact that a few months ago, back in January of 2024, I actually did make a video that very confidently stated that we might have actually solved the mystery here. But if you watch the video, the solution here was only for some of the circles, the ones with galaxies in the middle. And so for the most part, some of them are still kind of mysterious. But I guess the question is, okay, so what exactly is this and what are we looking at? Well, the overall assumption today is that it's possibly something like this. Some kind of a very powerful, some kind of a major emission from the middle of something, possibly a galaxy, that seems to form an object millions of light years across. 50 to 100 times larger than the Milky Way galaxy. And in order to produce something like this, you obviously require a tremendous amount of energy. Energy that has to come from somewhere. But for the most part, they're believed to be some kind of a spherical shock wave that was very likely formed at least 100 million to possibly several hundred million years ago. But one of the main issues explaining these objects is the fact that they seem to be so rare. If this is a typical galactic environment where galaxies emit a lot of energy all at once, we actually should be seeing this everywhere. Yet so far, less than 10 such objects have been discovered, and so far pretty much all of them only visible with radio light. Very likely the result of synchrotron radiation, or basically when various charged particles suddenly experience different acceleration or deceleration, such as fast electrons moving through magnetic fields. But usually when we see these emissions around, for example, a star or some kind of a cluster, they also do contain other emissions. For example, infrared light from maybe heated gas, or even X-ray emissions from much more powerful charged particles colliding with something else. But here, it's just pure radio light. And here's actually one of the most recent additional discoveries of yet another radio circle, discovered by using the famous South African telescope known as Meerkat. Now, the main discovery in this study was actually the unusual radio relics you see right here that seem to resemble two separate arcs. These are very likely formed through the same principle of electrons in the magnetic field, but they seem to be connected with the object in the center. Here we're talking about a galactic cluster with a somewhat long name PSZ2G277.93 plus 12.34. And so these strange radio relics, approximately 8.5 million light-years away from each other, seem to be a result of some kind of a galactic merger in the center of this very massive cluster. And though by itself it doesn't form a perfect circle, when the researchers were looking around this area, they actually found something else. They did discover a potentially new ORC, here referred to as ORC J1027-4422. This one is not as easily visible, but it seems to be there nevertheless. It's approximately 1.3 million light-years across, and when visualized in 3 dimensions, resembled something like this. But unlike those other ORCs we discussed in previous videos, including the one in the description that kind of tries to tackle this mystery even more, this one does not have a galaxy in the center. It's basically a single ORC without anything visible so far. But those other arcs they've detected were very likely produced through galactic merger and resemble this in 3 dimensions. And so maybe those arcs are just an incomplete circle, sort of pointing at some of the solutions to this problem. And according to the previous research from a few months ago, one of the best explanations for the formation of these orcs was actually the result of galactic interaction, and specifically the interaction of what's known as starburst galaxies. Here's a very famous example, the antenna galaxies, with the idea being that if inside of these galaxies a lot of stars explode at the same time, or at least within a few thousand years, the overall push and the force of these explosions is going to suddenly create a lot of wind traveling at thousands of kilometers per second, which by itself can actually happen if 2 massive galaxies collide in a certain way. Once again, antenna galaxies is a result of 2 colliding massive galaxies. And so this merger can actually push a lot of gas into an extremely small region somewhere in the center, which forces a tremendous star production, but also results in powerful emissions. And so in a nutshell, that's kind of what's believed is happening in at least 4 of these structures, because by looking at galaxies in the middle of at least 4 of these orcs, the researchers did discover signs of a major burst of stars that ended 1 billion years ago. And more importantly, a huge amount of very hot, very luminous gas that's usually the leftover of such events. But once again, this is only the orcs that have galaxies in the center. What about the other ones? Well, the other ones we still don't know. However, we now have another observation from a slightly different study that did discover something super surprising. For the first time ever, ORC has been associated with a different light from another telescope, X-rays. With the observations coming from the NASA's Newton telescope, with this new study that you can find in the description, basically talking about the origin of what they refer to as cloverleaf odd radio circle. This is actually the closest known to us, and because it kind of resembles a cloverleaf, it's received that nickname. And so when observing this region in the X-rays, they discovered this. Now this is actually on a much smaller scale, but there seems to be a somewhat circular X-ray component that basically shows us gas that's been heated and excited by something else. Although here it also reveals to us 2 separate groups of galaxies. There are approximately 12 different galaxies interacting here, and they all seem to be merging inside of this unusual formation. Or basically, inside of this formation as well. And in order to even produce these X-rays, the temperatures here have to be really high. Roughly around 8 million Kelvin or approximately 8 million Celsius, 15 million Fahrenheit. And so once again here, maybe this is a result of some kind of a galactic collision that then resulted in a production of a lot of stars. But galactic merger by itself cannot really explain this radio observation. Because once again, we see galactic mergers everywhere. But galaxies like this do not produce odd radio circles. So something else must be happening here in order to produce this formation that's millions of light years across. With one potential explanation involving central black holes. Here the scientists believe that maybe massive black holes in the center of these galaxies go through some super powerful activity, releasing a lot of energy in the process. But then, for some reason, all of the electrons produced by these emissions somehow become reaccelerated in certain locations where galaxies merge. And so here maybe this is because of 2 separate events happening at the same time. Emissions from a supermassive black hole mixed with a galactic merger that basically results in massive shock waves. But that's just a hypothesis, and right now, once again, the question still remains open. And since so far this is the only ORC directly connected to X-rays, technically we don't even know if these are related or if this is from two separate events that have no connection whatsoever. Nevertheless, this once again reminds us that astronomy, especially radio astronomy, is still in its infancy, and there are so many unexplained mysteries even today. The fact that this was only discovered in 2019 and the explanations right now are kind of very basic and not satisfactory already shows us that we still have so much to learn. As a matter of fact, if this is anything like FRBs or fast radio bursts, this mystery is not going to be officially closed for at least another decade. And today we're going to discuss some of the major updates in regards to one of the most fascinating astronomical events in the last few decades, the event known as BOAT, the brightest of all time. And here I'm referring to the image you see behind me of the event known as GRB 221009A. Now, a few videos in the description below describe this event in a little bit more detail, but in essence, this was the brightest and the most explosive event we've ever seen. So bright, as a matter of fact, that was observed by pretty much every major telescope on the planet, even the ones not designed to see anything, because in many cases, the radiation from this event passed through walls of these satellites and managed to affect their sensors in some way. And this was essentially the brightest, the most powerful, and the most incredible event we've ever seen and may ever see in the history of humanity. A gamma ray burst so powerful that it created an extremely bright flash from as far away as 2.4 billion light years away from us. And though obviously not the first gamma ray burst we've ever seen, when comparing this to other previous record holders, this was absolutely ridiculous. And it wasn't just powerful, it also lasted for a pretty long time, with certain afterglows even visible after 10 minutes, and a lot of additional wavelengths even visible 10 hours later. With all of this happening on October 9th of 2022. So basically like 2.5 years ago from when I'm making this video. And interestingly, even right now we still see some of the afterglow, mostly in radio waves, just because of all of the gas and all of the dust that's currently reflecting some of these emissions, even years after this event occurred. And back then, when it just happened, it was actually absolutely shocking, mostly because it basically literally blinded a lot of satellites and produced such a powerful emission that it even affected the atmosphere of planet Earth. Okay, let me repeat this again. This powerful event, even though it was 2.5 billion light years away from us, affected our planet. It influenced the ionosphere, it even influenced the radio communication, and in some sense, in terms of physical effects, resembled a typical medium-sized solar flare, and that's actually the intriguing part. This event was even seen by a lot of satellites that were actually designed to observe solar flares, and even studied by various solar physicists that were basically left completely dumbfounded. Until that point, nobody could believe that something like this was even possible, or that gamma ray bursts so far away can produce so much energy that basically they affect the planet in ways we usually expect from the Sun. Funnily enough, even the Voyager probe and the Mars probe currently orbiting Mars detected some of the emissions and then relayed them back to our planet. And a lot of this kind of made no sense, mostly because of the energy produced here. Here, in just 1 second, the amount of energy was equivalent to the entire Sun suddenly becoming pure energy and releasing everything into one direction. But surprisingly, nothing really bizarre happened here. As a matter of fact, additional investigations, including the ones you can learn about in the videos in the description, discovered that this was actually just a supernova. A Type 1c supernova involving a massive star, but a supernova nevertheless. Not some kind of a neutron star, not some kind of a magnetar, or some kind of a massive black hole destroying something in the process, but a supernova that basically produced the most powerful explosion we've ever seen. And what's really unique about this explosion, or this particular event, is actually the power of some of these photons that reached the planet. A lot of these gamma rays had energy measured in tera-electron volts. And I know this number might not really make a lot of sense, but let's just say that this is a super powerful gamma ray that humans cannot produce artificially, even in some of the most powerful particle accelerators. And here on the planet we actually have a few facilities designed specifically to try to detect these events from outer space. And normally we find like 1 or 2 every year. But in this case, the facility known as LASO, or Large High Altitude Air Shower Observatory located in China, designed specifically to detect high-energy particles and high-energy gamma rays, suddenly detected thousands and thousands in just mere seconds, all coming from the same point. And quite a lot of them had energy over 18 tera-electron volts, with some facilities even claiming that they actually detected something that was 250 tera-electron-volts, making these the most powerful gamma rays ever detected. But there is a slight problem with this detection, and actually with this whole idea of high-energy gamma rays coming from faraway distances. And it's really in regards to what we know about gamma rays and what we know about universe as a whole. There's a reason why we've never seen any gamma ray bursts, or really a lot of other gamma ray emissions, producing photons over 10 tera-electron-volts. And that's because, by design, a lot of these high-energy photons start to interact with other photons and usually transform as they travel across the universe. This astronomical concept is known as two-photon physics, and there are quite a few papers written about this, like the one right here by Alberto Franchischini, that in essence present the universe in high energy as somewhat opaque. Or just to rephrase this, extremely high energy photons do not pass through the universe without being converted into something else or without losing their energy. And so here, the more energy a photon has, the more likely it's going to be absorbed through the interaction with other photons, such as for example from the extragalactic background light. And normally there are two possible outcomes. Sometimes when these photons interact with some other light, they basically trigger the Einsteinian E equals mc squared and create particle-antiparticle, but in other cases they end up losing some of the energy, dropping from tera-electron-volts down to something much weaker. And though it's not a problem for a photon traveling for a few million light years, it does become a problem once these photons start to travel for hundreds of millions or even billions of light years. The probability of these photons interacting with some light and transforming becomes increasingly higher, which is why we don't really see a lot of high-energy gamma rays coming from distant locations. Yet strangely enough, in this case, we're actually observing something from 2.4 billion light years away, and not just one or two emissions. We're talking about thousands of photons with super high energies that in some sense violates this basic principle in astrophysics. In other words, we should not be seeing them, this should not be technically possible, and something here does not really add up and doesn't make sense. But in one of the recent studies, a team of scientists potentially proposes a really intriguing solution that might once again present us with evidence for a really exciting particle known as axion. Now, you might already know axions from some of the previous videos, but in short, this was a hypothetical particle proposed back in the days to try to explain some of the initial mysteries when it comes to the universe and the particles inside of it. And specifically, it was supposed to explain a very well-known physics phenomenon known as strong CP problem, which tackles the problem with symmetry when it comes to the idea of matter and antimatter. In short, it tries to explain why there's more matter in the universe compared to antimatter, while also tackling a few other problems. And while axion was one of the proposed hypothetical particles that might explain everything. And turns out that if it does exist, and if it possesses all of the qualities and all of the properties proposed by this hypothesis, it might also explain the mysterious dark matter. So basically here we have two birds, one stone. But in terms of mass and in terms of properties, it will be extremely low in mass and very difficult to find. Which is why it has not been discovered yet and would be difficult to discover using any known methods, except for maybe one. Turns out, when it comes to one of its properties, it also tends to interact with electromagnetic fields and specifically powerful magnetic fields, which often change axions into photons or sometimes change photons back into axions. In essence, forming what's known as an axion-like particle. It is essentially a photon, but it sometimes can turn into an axion depending on the strength of the magnetic field. And in the past, these unusual particles may have been potentially discovered when looking at extremely powerful magnetic fields around neutron stars. One of the older videos in the description tackles this potential discovery in more detail, but the main takeaway here is that sometimes photons become axions, and sometimes axions become photons. And turns out that this is really the only possible explanation we have right now for why these photons were visible from such an extremely far away distance. And so in this new study, Giorgio Galanti and his team proposed that in this event there might be a hint of axions, because the only way we can possibly see these super powerful photons coming from such a faraway distance, and especially photons that pass through a lot of different galaxies and a lot of different magnetic fields, is really if some of them, as they traveled away from this event, encountered powerful magnetic fields and actually turned into axions, then traveled for billions of light years, not interacting with anything, prior to basically becoming photons once again, once they reach magnetic fields closer to the Milky Way, transforming into photons once again. And while in that case, it makes a little bit of sense. It would explain why we're seeing so many of these particles coming from such far away distance, why they have so much energy, while also presenting us with basically first indirect evidence for axion-like particles coming from distant space, or at least involving thousands of particles as opposed to one or two. And the thing is, the researchers behind the study have previously made similar discoveries coming from distant supermassive black holes, or specifically blazars, as well. In other words, there seem to be other hints that these events are happening, and these powerful photons transform into axions all the time in order to travel long distances. But obviously this is just one of the explanations and one of the first potential propositions, so in some sense we just have to wait. This was such an incredible event that we're actually going to be studying this for possibly years and years to come, discovering so much more in the process. So only time will tell if the proposition in this paper makes sense, and if maybe we finally have our evidence for axions, and thus for the existence of dark matter as an axion particle. But at least for now, the conclusion from all of this is that, yeah, it's a mystery, we still don't know, but let's just wait and see what other studies and other scientists discover, because this is super fascinating, and this event is going to be teaching us so much more in the near future. And today we're going to discuss an unusual discovery from just a few years ago that created a new problem for astrophysics, and specifically for cosmology. A problem that the scientists now refer to as S8 tension. And so let's actually discuss what's going on here and what it all means, and discuss this recent study that basically confirms this once again. But I guess to start, let's briefly discuss the universe and what we know about it. Today, when it comes to modern cosmology, the most successful theory that most physicists accept is referred to as lambda CDM, the cosmological concept that proposes an expanding universe where the expansion seems to be caused by something we refer to as dark energy, but that also contains a component referred to as dark matter. And in this model, everything began approximately 13.8 billion years ago, when the universe started with the Big Bang. And so here, letter lambda represents this cosmological constant that basically represents the accelerated expansion, whereas CDM stands for cold dark matter. And for the most part, this model pretty much explains the majority of the universe. But in the last decade or so, scientists started to discover a few things here and there, mostly based on actual observational evidence, where things didn't really add up. And when things don't really add up, cosmologists refer to this as tension. And the most famous such tension is the Hubble tension, where the observations from the distant universe and the observations from the nearby universe seem to give us a slightly different value for the cosmological constant lambda. Now you can learn about this and the potential resolutions in some of the videos in the description, but today we're going to talk about this recently discovered tension referred to as S8, which basically represents a new tension, where S8 is a mathematical number or mathematical parameter that represents the amplitude of matter fluctuation. Or in more layman terms, it represents the clumpiness of matter, or how matter assembles into galaxies and into galactic clusters. And so if there wasn't enough tension before, we now get a new cosmological tension that has now been officially confirmed. But unlike Hubble tension that basically deals with dark energy, the S8 tension mostly deals with dark matter, the mysterious particle, or I guess mysterious phenomenon, that we know very little about. We actually have no idea what it even is, but we just know that it seems to exert huge gravitational influence on the entire universe, and we observe its effects everywhere. The most obvious example is actually in various observations involving gravitational lensing. And it's really in these observations that the researchers can measure this S8 tension by basically comparing predictions of clumpiness of the universe with physical observations. And so basically by conducting a lot of different observations focusing on various gravitational lensing surveys, in the last few years, cosmologists started to uncover discrepancies between the simulations, and here we're talking about simulations like the Illustris project that show us how galaxies and galactic clusters assemble, and actual physical observations from various telescopes. But intriguingly, at first it wasn't clear if there was actually something going on here, because the actual difference is extremely small. And so some of the first research was basically trying to discover if there is really anything going on, or if it's just some kind of an observational bias. And so exactly a year ago, in 2024, we discussed the first discoveries in a video in the description. This was one of the most comprehensive series of measurements that in 5 separate papers, with all of them in the links in the description below, definitively confirming this bizarre S8 or sigma 8 tension. Tension discovered by looking at datasets from the distant universe, so for example by looking at the cosmic microwave background, and then comparing the distribution of matter in this dataset with the distribution of matter much closer to us, visible in the gravitational lensing effects. And here this was based on a 6-year-long survey known as HSC, the Hyper Suprime Cam instrument on the Subaru telescope in Hawaii that for 6 years was used to study weak gravitational lensing effects. Essentially extremely small lensing effects that very often affect single galaxies, which often produce these minute distortions because of a lot of matter, and mostly dark matter, that's usually around them or in front of them. And here this was done by looking at 25 million galaxies that allowed the scientists to calculate the overall clumpiness. That's what the cosmologists refer to as S8. And the value for this clumpiness was discovered to be 0.763 to maybe 0.776. But here, a lot of things did not add up. Mostly because when calculating this by using CMB, or the earliest light in the entire universe, the value is much higher, 0.83, implying that the universe back then was basically clumpier. And that kind of doesn't actually make sense, because in the expanding universe, we kind of expect the opposite. As the universe became larger and larger, and as various galaxies came closer together, growing into larger and larger clusters, we basically expect the clumpiness to increase over time. Mostly because the matter starts out much smoother and eventually comes closer and closer, basically sticking together, kind of like clay or I guess oil, getting bigger and clumpier with time. Especially as all of these galaxies start to form the cosmic web, which basically makes everything inside this web much clumpier. And so here it was not entirely clear what's happening and why these observations had so much discrepancy, with one of the potential conclusions being, once again, maybe some kind of an error or some kind of a bias, which meant that we need observations from something entirely different. And well, now, exactly a year later, we get a new study by Shifan Chen and his team that does just that. It uses a different survey known as BOSS and reveals pretty much the same results. Here BOSS stands for Baryon Oscillation Spectroscopic Survey, which is also a huge galactic survey conducted over several years, although here using SDSS, Sloan Digital Sky Survey 2.5 meter telescope. And because here this survey focused on different galaxies and was even conducted using slightly different techniques, it presented a perfect opportunity to double check if this S8 tension would still persist or if it would disappear completely. And while the reanalysis based on the BOSS data still seemed to suggest that the universe is a little bit less clumpy than expected. Here the value seems to be even smaller, approximately 0.7, and much smaller than what's observed when looking at the cosmic microwave background. And to see if this is just a problem with calculations or maybe with the modeling, researchers behind this paper even tried to recalculate this using slightly different dark energy models, yet the values didn't really change much. There was still a discrepancy between the observations from the cosmic microwave background and the observations from much closer galaxies. And so here there was no clear solution. Scientists here don't actually know what the answer is or why this is happening, they just know that there seems to be a 10% discrepancy between the distant universe and the nearby universe. And even though in every computer simulation we basically end up with much higher S8 or much higher clumpiness, the actual observations based on telescopes suggest an unusual 10% discrepancy. This was even compared to one of the most recent and most advanced simulations known as Flamingo that basically recreated a huge chunk of the universe extremely accurately. Yet the results were the same. Something in the universe, in the real universe, seems to suppress galactic growth or even cosmic growth, preventing galaxies and galactic structures from sticking together and from growing bigger. And because this idea and this clumpiness, or even the clustering of galaxies and the formation of galactic clusters, is usually used to understand the entire universe, this 10% discrepancy is technically a pretty big deal. It means that there's something we still really don't understand about the evolution of the universe, or maybe our theoretical models are incorrect after all and need to be fixed. Specifically models in regards to galactic growth and the formation of clusters. And though it's still possible that maybe there is some kind of an observational mistake, or maybe even a calculation mistake, right now, based on so many papers, the evidence for this tension seems to be pretty strong. Which means that the only way to answer all of this is, of course, more observations, more data, and more studies. And luckily for us, we're going to get more data from the Dark Energy Survey really soon, which might actually help us figure out what's happening here. Either way though, right now it just looks like we have two major problems. We have the problem with dark energy that seems to be different from the early universe and the universe near us, and now we have a problem with dark matter, or the stickiness, clumpiness of the universe. It also seems to be different between now and 13.8 billion years ago. Neither one of these problems right now has any resolution. And today we're going to discuss a discovery of a very strange pulsating object that currently does not make sense, and according to the researchers, should not actually be possible or exist at all. And that's because, based on the observations and the recent discovery, this new object, known as ASCAP J1839-0756, seems to be producing a lot of pulsating emissions we've never seen before, and that cannot be explained using modern physics. And so let's discuss this unusual object in a little bit more detail, but I guess let's start with the discovery first. And well, the first hint for the existence of this object was from the Australian radio telescope known as ASCAP, also known as Australian Square Kilometre Array Pathfinder. This telescope is actually known for producing the biggest radio map of the night skies we've ever had, and we'll discuss this in one of the previous videos in the description. And so during its normal operations and normal observations, there was one unusual signal that kind of stood out because there was really nothing around it. Here this appeared to be as an extremely strong radio signal that was at first getting brighter, but then started to dim, with its brightness going down by about 95% in just 15 minutes. And this was already kind of unusual and actually has not been seen before. For example, instead of a typical fast radio burst, this was actually an extremely slow radio burst. And so it wasn't clear exactly what happened here or what produced this emission. Overall, the emission looked something like this, which meant that additional observations would have to be required in order to find out what's up here. And that's exactly what the scientists recently did, in the process uncovering a lot more emissions, especially when combining this with several other telescopes, including the famous Meerkat from South Africa. And this time, instead of a single emission, they actually discovered that this is a periodic emission that happens extremely slowly, with the new data suggesting that it takes approximately 6.5 hours between pulses. Or basically that this is indeed a pulsating radio object, but with an extremely long period we've never seen before. And this is basically where it kind of makes no sense. And I guess let me explain why. Normally, when it comes to pulsating radio sources, we usually detect them from various neutron stars, the most common one being a pulsar. And so typically what we actually see from pulsars is basically one of their beams pointed almost directly at us, with the periods corresponding to the wobble of the pulsar as it spins around its axis. And obviously in the last few decades, thousands and thousands of pulsars have been discovered pretty much everywhere, some of them spinning ridiculously fast, up to approximately 700 times per second, and you might actually want to check out one of the recent videos where another such pulsar potentially established a kind of a spinning limit when it comes to the maximum velocity. That video should be in the description below. And some pulsars spinning much slower. But to date, the record for the slowest spinning pulsar seems to be 23.5 seconds per rotation. This pulsar was discovered by the Chinese radio astronomers approximately 7 years ago. But in the last few years, researchers also started to discover unusual long-period radio pulsators, or radio transients as they're also known, which turn out to be some kind of a new class of objects where they basically still get to emit radio waves, but they're just doing so much slower. Here the period usually ranges between 18 minutes to maybe 54 minutes. So hundreds to thousands of times slower than a typical pulsar. And that actually did not make much sense, mostly because of how we think it works for a typical neutron star. In order for a pulsar to produce these radio pulsations, it has to actually spin pretty fast. And so in a typical pulsar, it's really the rotation of the magnetic field that has to happen really fast that produces these radio emissions. And that's because this magnetic field basically acts as a kind of a particle accelerator that accelerates various electrons that were produced as a result of gamma radiation coming from the neutron star interacting with the magnetic field around the pulsar. And so essentially, through this rotational interaction of the magnetic field, a lot of these electrons are accelerated to very high velocities, which produces radio emissions in two separate directions following the magnetic field. But the object has to be spinning really fast for all of this to work. And so according to modern theories, it has to spin at least once per minute. Otherwise, it's actually going to stop producing radio waves because the magnetic field is just not going to be able to create any of this anymore. And so the previous detection of these long pulsators already produced a bit of a mystery. But here there might be one explanation. Maybe these are actually not pulsars but possibly magnetars, which could be producing these emissions in some other way through a different mechanism involving a much more powerful magnetic field. Or alternatively, these could be highly magnetized white dwarfs, which would be spinning much slower and may have similar magnetic properties, allowing them to pulsate in a similar way. But so far, individual white dwarfs have never actually been found to have these unusual pulsations, or at least that was the explanation for previous detections of these long-period oscillators detected in the last few years. And here we're talking about pulsations in minutes. But now we have a different story. Here, whatever is pulsating is doing so every 6.5 hours. And that's completely unexplainable. This would be the slowest pulsar ever discovered, and a pulsar where the mechanism cannot be explained using any technique. For example, can this be a magnetar? Well, pulsating magnetars have been discovered before, and actually with even slow pulsations, but all those pulsations were in the X-rays, not in radio light. Here's actually one of these examples, the magnetar 1E 161348-5055. That's technically a supernova remnant that produces periodic X-ray emissions every 6.6 hours. But here we see no X-rays, only radio light, which would make the magnetar explanation very challenging. Now, could this be some kind of a magnetized white dwarf? Well, usually white dwarfs produce other emissions as well, and in this case, no signs of white dwarfs have been seen so far, and no additional emissions or additional observations seem to be visible. Basically, no evidence for this being some kind of a white dwarf either. And so if not a magnetar, and if not a white dwarf, and if it cannot be a typical pulsar, what is this? What can possibly produce super strong radio emissions every 6.5 hours, yet produce no other emissions visible so far? And the answer is, I don't know, actually nobody does. This is basically a new, completely unexplainable, mysterious object. But what makes this object even more mysterious is the fact that even trying to model this or explain this physically just doesn't make sense. But we do have some hints based on what we know about pulsars and neutron stars. In other words, there's maybe a hint that this is a neutron star. And this is actually based on the orientation of the magnetic field compared to the rotational axis. So normally, in a typical pulsar, the rotational axis is just a little bit misaligned with the magnetic axis, which is actually one of the reasons pulsars can pulsate, beaming their light toward us. But in this case, for this pulsar, its magnetic axis seems to be almost at 90 degrees from the rotational axis, because during one of the observations, it was actually determined that it seems to produce a second flash after about 3.2 hours. This is known as the interpulse, and it's basically coming from the opposite direction, but it's not directly pointed at us, so it's much more difficult to see. And this apparently happens to approximately 3% of all pulsars we've seen so far, implying that this is maybe some kind of a really bizarre neutron star we've never seen before. But the problem is, of course, the fact that this spins so slow. All of the previous detections were spinning at least several times per second, and in every single case, over time as the pulsar slows down, we expect these radio emissions to stop completely. Nevertheless, there is still at least one hint right now that this is maybe a magnetically driven process from some kind of a very bizarre neutron star. Or, I guess, aliens. Well, maybe not aliens because the emissions here don't really seem to produce anything resembling artificial communication. Either way though, there is definitely a huge mystery now. The mystery of what exactly this is, how it works, or even how far away this object is from us. At this point, all of this is still unknown. Now, chances are if we actually discover similar objects somewhere out there, it will become much easier to explain them, but for now, many of these long-period pulsators discovered in the last 3 years don't really make a lot of sense. And though it was already difficult to explain pulsators with 50-minute periods, here we have to now explain one with 6.5-hour period. Which means that for the next few years, this is most likely going to be rewriting a lot of physics books, and may even end up producing some kind of a new model about neutron stars, or even discover some kind of a new object we never knew existed before. Maybe this is actually some kind of a bizarre quark star, or something else really exotic that we could not imagine before, but that was always right here, sending signals to us, just extremely slowly, so this is the first time we've detected it. And so at least for now, ASCAP J1839-0756 is going to become a new radio mystery, joining the ranks of FRBs and a few other emissions we've discussed in some of the previous videos that still cannot be explained. And it looks like we have a new mystery. A mystery in regards to a completely new type of an explosion. Here we're talking about a cosmic explosion, or basically a space explosion, something astronomers usually call a transient, that has never actually been seen before and has now been officially identified as something entirely new and something potentially very important. But in this case, because this type of an explosion is not actually that powerful and is not really that bright, it's now referred to as a Millinova. So kind of like a supernova, a kilonova and so on, but in this case, much weaker. As a matter of fact, it's even weaker than a typical nova explosion, which usually occurs on a lot of different white dwarfs. But in this case, surprisingly, it might have a somewhat similar mechanism and potentially even comes from somewhat similar objects. And so let's actually talk about this new discovery in a little bit more detail, but let's start with the discovery first and with where and how all of this was found. And it kind of started with this. This event is known as Assassin 16OH, not because this is an assassin killing someone, but because in this case this is an acronym that stands for All Sky Automated Survey for Supernova. So basically the main purpose of this survey was to discover various transients, usually various supernova. It's an automated survey, so it basically detects them and reports them almost right away. And a few years back, it detected this one that was actually very bizarre for a lot of different reasons, with the biggest reason being the types of emissions. Here, it surprisingly was not very bright in the optical emissions, so basically it didn't change much in brightness when looking at this with a telescope, but when combined with the X-ray observations, things looked very different. It seemed to produce extremely powerful X-ray emissions, but the X-rays here were low in energy, usually referred to as soft X-rays, basically suggesting some kind of a really hot gas, possibly hundreds of thousands of degrees in temperature, as opposed to temperatures of millions of degrees. But here these X-rays were very different from a typical star and were actually pretty bright, so this basically did suggest some kind of a nova-like event, or basically suggesting some kind of a white dwarf or something similar to a white dwarf, very likely having a lot of really hot gas around it, suddenly forming huge explosions and a lot of heat. And that's because usually these soft X-ray emissions have always been associated with white dwarfs. But unlike in previous emissions, or unlike in previous nova, the optical emissions were surprisingly dim. And that's because normally in a typical nova, what actually happens is you have two stars. You have a white dwarf and some kind of a companion. That companion is essentially a donor, and it makes the white dwarf accumulate a lot of mass, which at some point becomes so critical and so dense that it basically initiates a nuclear reaction on the surface, literally exploding like an enormous nuclear bomb, which obviously produces X-rays, but also produces optical emissions. And because this is a periodic event, it also sometimes happens relatively frequently. But because in this case there was no optical counterpart, that's why this particular transient became a bit mysterious. So basically here, no signs of nuclear fusion were detected, yet we still had X-rays, so something was definitely heating up the gas. And in the last few years, several models have been proposed, but they basically all involved a white dwarf. For example, some kind of a really massive white dwarf, 1.1 solar masses in mass, very likely accreting mass from its partner, but the mass that was actually not exploding as much and instead was depositing on the surface and very likely heating up in the process. And in this case, because this mass was not exploding and was depositing, it made the white dwarf grow over time. And this is actually an important fact I'm going to come back to in a few minutes. But at first, following this initial detection, scientists thought that maybe this is just some kind of a weird object and some kind of an exception. But not everyone thought so, and so in one of the recent studies, a team of Polish astronomers, whose names I'm not going to try to pronounce because Polish names, published this very interesting new paper proposing a new concept and a new type of an explosion, Millinova. And that's because they've conducted a relatively thorough search using over a decade of observations, and specifically 20 years of data, from the Polish-based survey known as OGLE, or Optical Gravitational Lensing Experiment, which allowed them to uncover a lot more of these objects relatively close to us. And specifically here, they now discovered 29 of these unusual objects, mostly located in the Magellanic Clouds, the satellites of the Milky Way galaxy, that all exhibited extremely similar behavior and produced very similar emissions. And so here's how the scientists now define these Millinova. First of all, they all have to have a relatively long-lasting outburst. It has to last at least several months. Second of all, here the brightness of the object has to increase by at least 10 times, in some cases 20 times, but not too much. This is why they're called Millinova. But more importantly, they have to get brighter in the X-rays and not really the optical light. And that's because in this case, it basically represents a huge deposition of gas from the star on the surface of the white dwarf that doesn't seem to lead to the typical nuclear explosion we expect from the nova. Or in other words, the X-rays in this case seem to be produced by huge amounts of material that falls on the surface of this white dwarf, releasing some energy in the process, but not exploding. Although some alternative explanations suggested some nuclear explosions, just much smaller in size. But the explosion is not violent enough to basically expel everything from the surface like it usually happens in a typical classical nova, which we've seen many times before, by the way. And in order for this to happen, you basically have to have two stars relatively close to one another, one being a donor and one being a white dwarf. And the orbit between them has to be pretty close as well, with a period of just a few days. But in order to confirm some of this, researchers also focused on one of these objects and tried to analyze it in as much detail as possible. Here this is the object referred to as OGLE M-NOVA 11. The object that began its outburst in November of 2023, and the object that was now seen with the Southern African Large Telescope, one of the largest telescopes on the planet. And so by looking at this star, they now saw definitive signs of ionized helium, also carbon and nitrogen, whose ionization suggested super high temperatures. But then, through additional observations using the NASA Swift Observatory, they also discovered X-rays that suggested temperatures of 600,000 degrees Celsius. And because this object was about 160,000 light-years away from us, it basically suggested that whatever this was, it was only about 100 times as luminous as our Sun, which for a typical nova would be extremely dim. So this was definitely a much smaller explosion. But the super hot gas, very powerful X-rays, and the sudden increase and then decrease in luminosity basically suggested a transient event, which seemed to resemble other 29 events in every way. They actually all seem to have this unusual triangular shape, and even seem to have relatively similar power, essentially suggesting a similar source and very similar physics. Although strangely enough, some of these objects seem to also repeat these outbursts every few years, which once again highlighted that this is probably a white dwarf and some kind of a partner. A lot of recurring nova actually repeat in a very similar way. But, once again, because these were so much dimmer and produced so much less power, they have now been named Millinova. And that's actually because at their peak, their brightness is approximately 1,000 times weaker compared to a classical nova and millions of times lower than a typical supernova. But because so many of these events were discovered in the Magellanic Clouds, this is why it gets kind of interesting, because now several studies have also suggested that this is probably something super important. Specifically, several other studies that focus on these events have now proposed that this is very likely an actual candidate for the famous Type 1a supernova. Or basically what we're looking at right here is the progenitor for a Type 1a supernova that scientists have always used as a standard candle to measure distances in space. I mean, that famous concept of dark energy was only discovered because of the measurements of Type 1a supernova from extremely distant galaxies. And that's because usually Type 1a supernova produce very similar explosions with very similar brightnesses. And this only happens when a typical white dwarf reaches its Chandrasekhar limit, approximately 1.4 solar masses in mass. And that can only happen if the white dwarf continuously accumulates mass on its surface, growing more massive every single year. Now in a typical classical nova, because a lot of surface material basically explodes, dispersing in the process, this could take a really long time, billions of years, possibly longer. But in this particular case, or in these 29 cases, because the explosion doesn't actually disperse the material, with most of the material and most of the gas depositing on the surface, some of the initial calculations from two of these events calculated the mass deposition to be approximately 1/1,000,000th of the solar mass per year, which means that within approximately 3 to maybe 10 million years, quite a few of these white dwarfs would actually reach their limit and very likely go supernova. In other words, just to rephrase this, based on the calculations from this event, for example, Assassin 16OH, assuming this hypothesis is correct, in less than 20 million years, it might actually create Type 1a supernova as well, as the white dwarf grows in mass and as it eventually reaches its critical mass. With the main question from all of these studies right now being, did we actually finally discover a prototypical example of a Type 1a supernova, and is this really how they all form? And that's because previously it was not certain what the progenitors for these very famous supernova were. Like I mentioned, in a normal nova, the explosion is so powerful that it basically disturbs a lot of gas around the white dwarf, making it very difficult for a typical white dwarf to accumulate mass effectively. But here, because the explosions are so much weaker, and because the mass deposition seems to be pretty high, based on the X-ray emissions at least, it means that these white dwarfs are going to be growing very fast and only have a few million years to go before reaching their critical mass. And if so, then the question is, I guess, what makes this different from a typical nova? Or in other words, why do some white dwarfs produce millinova, some produce nova, and some produce something entirely different? Why does the gas around white dwarfs explode in different ways? And what causes some explosions to be much smaller than others? Now right now, because this is a brand new discovery, it will obviously take a few years to figure this out, but once more similar objects are discovered in, for example, our own galaxy, maybe a little bit closer to us, and once scientists are able to analyze these objects even longer, we'll probably get some of our first answers and finally figure out what's going on here. For now though, it really looks like these millinova might be the best progenitors for the famous Type 1a supernova, which will obviously help us understand how all of this works, maybe even helping us predict one of these events before it actually happens, allowing us to observe this possibly in almost real time. And so yeah, we have a new mysterious explosion called millinova, and there seem to be at least 29 objects out there exhibiting these bizarre explosions. And in this video we're going to discuss yet another somewhat bizarre discovery that's currently very difficult to explain. A discovery of potentially a completely new type of an explosion, an extremely powerful explosion, coming from a distant galaxy that we've never seen before. And based on observations from several different telescopes and the analysis that took several months, we're now pretty certain that whatever this is, it's never been seen before and was very likely caused by something ridiculously powerful. And so let's discuss this event in a little bit more detail, starting with how this was discovered and of course why this was so unusual. And this is the space telescope that discovered this explosion. This is known as the Einstein probe. A relatively recent addition to space telescopes, and the one that we still haven't heard about much because it just started operating, but this was a joint mission by the Chinese Space Agency and the European Space Agency, along with the famous Max Planck Institute for Extraterrestrial Physics. And so this telescope actually launched almost exactly a year ago, in early 2024, and almost right away it started to discover some really bizarre phenomena. But unlike other telescopes like the Hubble and the James Webb, this is a purely X-ray experiment. And its main purpose is to try to find various high-energy transients or high-energy explosions, which is why it was designed to detect X-ray emissions that change dramatically over time. And here it essentially focused on three main goals: powerful events such as merger of neutron stars, that can then be linked to various gravitational waves, various inactive or quiescent black holes that once in a while produce X-ray emissions when something tiny falls into them, and any additional X-ray phenomena that might resemble some kind of a powerful explosion. And almost right away, within just a few weeks, it already discovered several explosions visible in the X-rays, which in most cases were then linked to a lot of well-known explosions such as, for example, GRBs, gamma ray bursts. And gamma ray bursts, or GRBs, are essentially some of the most powerful explosions that we've ever seen anywhere. Intensely energetic events, usually happening in distant galaxies, which usually emit tremendous amount of energy in under 2 seconds. As a matter of fact, the most powerful explosion we've ever seen was also a GRB. The so-called brightest of all time only happened a couple of years ago and is definitely something we've never seen before. The video in the description talks about this a little bit more. But normally, a gamma ray burst is also followed by tremendous X-rays that can actually last much longer and are then followed by ultraviolet, optical, infrared, microwave, and even radio frequencies. Which is why this telescope was actually linked to a lot of other telescopes in order to find and study more GRBs and to uncover their mysteries. But today, based on thousands of different detections, it's basically believed that GRBs are caused by one of two phenomena. Either two neutron stars colliding, forming a black hole and exploding in the process, as well as releasing huge amounts of gravitational waves, or, such as the case of the GRB 211009A, also known as brightest of all time, a massive star collapsing under its own gravity, forming a black hole, but also exploding with a tremendous power. And so in all of these cases, these events form these super bright jets that travel for billions of years and can easily be seen from anywhere. And so in some sense, one of the main goals for this telescope was to observe these events by using X-ray wavelengths. Mostly because this is the most sensitive and the most accurate X-ray space telescope, and it would allow us to observe things we've never seen before. But while looking for these high-energy transients and while monitoring the night skies, On March 15th of 2024, the Einstein probe detected something really bizarre. This was an X-ray burst coming from approximately 12.5 billion light-years away from us, and it lasted for approximately 17 minutes. This was the longest such event we've seen in the X-rays. And while at first it was believed to be another gamma-ray burst, potentially a super powerful one, and possibly caused by some kind of a collapsing star once again. And obviously, in order to determine exactly what the scientists saw, they had to rely on other telescopes. Interestingly, approximately 1 hour after the X-rays, the South African ATLAS, or the Asteroid Terrestrial Impact Last Alert System, has accidentally detected optical light coming from the same location, with a follow-up using Very Large Telescope and the Gemini North Telescope, confirming that this was a burst from approximately 12.5 billion light-years away from us. But compared to other GRBs, something here was really not adding up. At first, the scientists could not see the gamma rays. As in normally, in a gamma ray burst, following the X-ray emissions, we usually see powerful gamma rays coming from the same location almost right away. And so in a typical GRB, X-rays are observed first, and then after just under 1 minute, we usually see gamma rays. And interestingly, it actually took a lot of digging to actually find out what's happening. And it turns out that there was a gamma ray explosion, but it happened much later. Here the gamma rays were eventually detected, but they happened minutes after the explosion, with such an unusual long delay never observed before. And so combined with a very long X-ray emissions and a very long delay between X-rays and gamma rays, something here was already not adding up. And well, to try to resolve exactly what happened here and what caused this explosion, Brendan O'Connor and his team, along with a different team led by Roberto Ricci, conducted additional observations and additional search by using other telescopes, and actually a lot of telescopes, NuSTAR, Swift, Gemini, Keck, ATCA, NICER, and DACCAM, in order to basically dig out as many different wavelengths as they could. This was a combination between ground-based and space-based telescopes, and the focus here was on figuring out what kind of a transient this was and what caused it. And looks like that assumption that this was just a GRB was potentially incorrect. Mostly because in this case this explosion did not match typical GRB observations and was potentially an entirely new, rare class of powerful explosions that's never been seen before. So basically here, comparing this to different explosions, it will have certain properties from supernova, certain properties from tidal disruption events, and certain properties from GRBs, but doesn't seem to resemble any one of them, instead borrowing a few properties from here and there. For example, it was just a little bit too long to be a GRB, but a little bit too short to be a tidal disruption event. It was also extremely bright, and this high luminosity from such a far distance only means a very powerful event, but it also came from a location where there really doesn't seem to be anything too active or anything producing major emissions. But in order to solve this mystery, scientists just had to wait a little bit. Mostly because when it comes to GRBs or a lot of other powerful emissions, they always start with high energies, so gamma rays and X-rays, and eventually start to emit visible light, radio light, and microwaves. So basically here researchers were trying to wait for the radio emissions in order to discover additional details. But that's where the mystery started. The Very Large Array, the extremely powerful radio telescope in New Mexico, did not see anything. And normally when we detect gamma rays and X-rays, we basically always see radio light afterwards. And that's actually because there is a lot of dust in the area, and as these jets collide with all of this dust, the external shockwaves usually generate radio waves. And that really did not make sense if this was a GRB, or even if this was some kind of a supernova, and actually did not resemble any powerful event we've seen previously. And so the only possible explanation that kind of made sense here was basically a jetted tidal disruption. This is a rare cosmic explosion that usually happens around massive black holes, and normally involves a star being teared apart, causing a release of materials in two directions along the magnetic jets. And these jets often produce X-rays, but they also are supposed to produce radio emissions. Except that in many cases, these radio jets take much longer to reach us and might be months or even years behind. Which means that the best explanation for this strange event is basically a black hole absorbing a star. But only if we see radio emissions in the next few months. And that's because so far we've only discovered 100 such events, and in every single case, we always see radio emissions following the event. So basically here, the only way this can be a tidal disruption is actually if we see some kind of a radio emission in the next few months. But the question is, what if we don't? Now normally if these radio emissions do come, they should be visible for years to come, so at some point one of the radio telescopes should be able to see them from this location. But if we don't, by let's say 2028, then this is indeed a completely new class of an object. Possibly a new type of an explosion we've never seen before, and possibly caused by something exotic and something really bizarre. In this case, since it basically came from some kind of an unknown host or some kind of a quiet galaxy, it's going to be really difficult to find out exactly what this is. And since the gamma ray emissions were also not particularly bright, yet the X-ray emissions were visible even after 5 days, right now the black hole explanation is the only one that potentially makes sense. And so the scientists behind the recent study do think that maybe this is some kind of a white dwarf being completely destroyed by some kind of a smaller intermediate mass black hole, which is why we're seeing emissions that are so much weaker, but also so unique. Because in this case this is an intermediate mass black hole and not a supermassive black hole, it's possibly producing very different emissions with very different time frames, and since we're not seeing any radio light, it possibly just doesn't have anything around it to create shockwaves, or maybe the disrupted star, the white dwarf, was just completely destroyed right away, leaving nothing in the process. Either way, at least for now, EP240408A is going to remain a mystery, a never-before-seen event with extremely powerful emissions, but predominantly in the X-rays and visible from really far away. Right now, this doesn't have a name, it doesn't have a good explanation, and we may not have an explanation until we see those radio waves. But this is obviously not the first time bizarre explosions have been discovered, and not the first time we find such a strange mystery. And in this video, we're going to be discussing a completely new discovery of what seems to be the largest, or at least the most massive structure we've ever seen anywhere when it comes to enormous superstructures in the universe. And specifically, we're going to be discussing a discovery that honestly our puny human brains cannot even comprehend. A structure that seems to contain approximately 200 quadrillion solar masses and is over 1 billion light years across. But I guess if we were to visualize it, it would maybe look something like this in the night skies. And so let's talk about this new structure that scientists are now calling Quipu in a little bit more detail and discuss why this is important and what it means for cosmology. But I guess first let's start with something you might be familiar with from some of the previous videos. And this was a discovery from just over a decade ago of the superstructure we seem to be a part of, Laniakea. And here the Milky Way galaxy, which you can obviously see right there on the outskirts, is just one of 100,000 or so galaxies that's inside this galactic supercluster that was discovered in 2014. And in essence, it's a combination of different clusters all together moving toward a certain point. A point that seems to attract all of the galaxies near us, and a point that you see right there where everything seems to kind of join together. Although it can also be visualized this way if we imagine everything with the Milky Way in the center. But sometimes last year we discussed a new discovery with the researchers identifying an even larger structure that Laniakea was actually connected to. You can learn about this in one of the previous videos in the description, but in essence it resembled something like this. And here this was referred to as the Shapley concentration, with everything essentially connected gravitationally and to some extent moving toward the famous Great Attractor. The unusual gravitational attractor hundreds of millions of light years away from us that seems to for some reason attract all galaxies, with all of them heading that way. You can learn more about the Great Attractor mystery in one of the previous videos in the description. But even here, trying to imagine the size of these objects would be kind of challenging, because here we're basically looking at something that's approximately 500 million light years across. And since our galaxy is only 100,000 light years across, this whole structure would be at least 5,000 times bigger. And so from a human perspective, not a lot of this makes sense, because in terms of size this is just completely incomprehensible to us, and can only make sense if you use mathematics, large numbers, and maybe miniaturized maps like the one you see behind me. But apart from all of these discoveries, somewhat unrelated to this, in the last few months we also had official confirmations that cosmology has a bit of a problem. At least in terms of measuring things like, for example, the Hubble constant, and a few other constants such as the S8 constant we've discussed previously in some of the videos in the description. And so these very unusual cosmological issues, at least based on some of the modern observations, also do not make a lot of sense. Which is why some scientists propose that maybe we can explain some of these cosmological issues by trying to understand how the universe is structured, because maybe the reason we see universe expanding at different velocities or different accelerations is really because of the structure itself, not so much some kind of a problem with cosmology. And so because of this, many cosmologists have been trying to map some of these largest structures out there in order to understand how matter is distributed and how light is bent as it travels through these structures. Because in some locations we seem to have a lot of density, but in some other locations we actually find a bunch of voids, basically empty space. And so to try to understand how cosmology works, and to try to find the exact value for these constants, we do have to understand the effects of these large-scale structures. And that was the main premise behind the discovery of what now is referred to as QUIPU. The study by Hans Bohringer and the international team of scientists used a relatively large sample of galaxies to map the overall distribution of all of them, in the process discovering 5 independent clusters, all visible in different color here, and all containing large groups of individual galactic clusters and superclusters, but connected gravitationally similar to Laniakea. And here the one you see in red seems to be the biggest. This is now known as QUIPU. And QUIPU is a pretty cool concept. In essence, this was a way for different South American civilizations to communicate. Specifically, Incas used these knotted cords as a type of a recording device to, for example, store numbers or other information. Honestly, it's a pretty cool concept, but maybe not for this channel, and I'm sure other channels have done a better job explaining this. And so here, because this superstructure also kinda looks like a long filament with knots, they decided to name it QUIPU as well. And this is an enormous object. As I mentioned before, 200 quadrillion solar masses and 1.3 billion light years across, which is at least double the mass of Laniakea and triple the length. And so because this is basically the largest, or at least the most massive structure we've ever seen, for cosmologists this is obviously a pretty exciting discovery. A discovery that can definitely help us understand galactic evolution and potentially improve our understanding of various cosmological constants. Mostly because, as you can see from this image, here the density distribution is very different from the rest of the universe. For example, the density inside these galaxies seems to be much higher than the density in individual clusters, or less massive clusters, which would obviously mean they contain more mass. And this of course produces different lensing effects. It also produces different types of redshift as the light travels through this, and also extremely likely produces some kind of an imprint in the cosmic microwave background that has not been investigated yet. But because cosmological constants such as the Hubble constant are usually calculated using both CMB and the observations from various galaxies, understanding the effects of these superstructures is something that needs to be taken into consideration, because maybe this is why we even have this Hubble tension to begin with. We actually discussed this concept extremely recently, the video link should be in the description, but here the distribution of matter in the universe might be one of the explanations. And that's because the gravity from these superstructures extremely likely modifies the cosmic microwave background through what's known as integrated Sachs-Wolf effect. It essentially is the reason why CMB appears a little bit uneven and is basically the result of a gravitational redshift. But I guess one of the questions you might be asking is, okay, but what exactly are we actually looking at here, and what does any of this mean? Well, in essence, every one of these red dots, that's a galactic cluster, usually a really large one. For example, here's the famous Coma cluster visible right here. A bunch of galaxies neighboring one another. But in this case, all of them are also connected to each other and basically have a gravitational link influencing each other's motion, which is essentially how this one superstructure is formed. But they actually found 5, all close enough but not really connecting. Here the distance is kind of difficult to imagine, but it's in hundreds of millions of light years. But interestingly, these 5 superstructures seem to actually contain approximately half of all known galactic clusters and approximately 25% of all matter, but within just about 13% of volume. So basically these are extremely high in density regions compared to everything else. But they also don't seem to break any cosmological models when it comes to galactic formation. And so here, when researchers compare this to various supercomputer simulations that try to create galactic superstructures, in those simulations, very similar superstructures also seem to appear. All of them end up containing thousands of different galaxies and lots of very hot intra-cluster gas. Gas that's hot enough to start emitting X-rays. And it's actually these X-rays that allow scientists to discover all of this. In other words, here what you're looking at is actually X-ray observations of very hot hydrogen gas inside these galactic superstructures. This was from a survey known as CLASSICS, Cosmic Large-Scale Structure in X-rays Cluster Survey. And it basically shows us where a lot of this hot gas seems to be concentrated, which surprisingly seems to prefer these galactic superstructures as opposed to smaller clusters. But all of this is probably because of this enormous mass. The mass of these superstructures is so large that it seems to influence a lot of this gas to move faster, to collide with more intensity, and to thus produce more X-rays. But this structure is not forever. As a matter of fact, as a result of the expansion of the universe, it is going to at some point fall apart. And so at some point in the future, all of these superstructures will break apart, collapsing into smaller structures, and then eventually into individual galaxies. But because inside these structures the galaxies are already moving pretty fast, and seem to be moving in a certain direction, taking all of this into consideration is kind of important for cosmological studies. Mostly for the sake of measuring cosmological constants, and for trying to solve these two major mysteries we have in regards to cosmology, the Hubble tension and the SA tension. Once again, the links in the description talk about both of them in a little bit more detail. And today we're going to discuss a detection of what seems to be one of the most important gravitational wave events we've ever seen, and it was actually just detected a few days ago from when I'm making this video. An event that we still know very little about, and the event that might change our understanding of the universe once again. And so let's discuss this event that you can learn about in some of the links in the description, and talk about what all of this means and why this is so important. But first, just a little bit of history, just so that you understand why this is important. And well, the history here is surprisingly short, because the first detection of gravitational waves only happened just under 10 years ago. The event known as GW 150914 was the first official confirmation that gravitational waves are real, and black holes can indeed collide with one another and produce space-time disturbances predicted by Einstein over 100 years ago. But within just 2 years, something else even more important was discovered 140 million light-years away from us. This was GW 170817, and it was the first time ever gravitational waves also coincided with something else, actual electromagnetic emissions visible by different telescopes. Because in this case, we actually discovered the first ever neutron star collision that produced what's known as a kilonova. And this was a tremendous event. It actually led to some tremendous discoveries, such as, for example, discoveries of how a lot of atoms seem to be produced, but much more importantly, it was a confirmation that what's known as multi-messenger astronomy can definitely work. In other words, it's possible to observe astronomical events by using completely different telescopes. In this case, by observing gravitational waves and electromagnetic emissions. And here, some of the first signals visible in gamma rays arrived to our planet approximately 1.7 seconds after the gravitational waves. Intriguingly, this unusual delay resulted in some important discoveries in cosmology, including discoveries in regards to dark matter. As a matter of fact, this was actually one of the biggest proofs that dark matter might be real, and ideas like MOND may not be entirely correct. And that's because the MOND hypothesis predicted that gravitational waves would be traveling much slower. But what's even more intriguing is that even after the gamma ray observations, additional signals were detected from the galaxy NGC 4993, visible to a lot of different telescopes, including optical telescopes, as you see in this image. So here everything was observed literally in real time. But unfortunately, for the past 8 years now, nothing like this happened again. As a matter of fact, almost 3,500 candidates have been discovered and 195 have been officially confirmed. This is on February of 2025, by the way. But out of all of these candidates and detections, only one of them was basically multi-signal. Everything else was only visible as a gravitational wave. And that's despite the fact that we've seen a lot of different things collide over time. Different types of black holes of different types of masses, some of which scientists still have trouble explaining. We've also seen collisions between a black hole and a neutron star, 2 neutron stars, and even objects that were somewhat difficult to explain. You can learn about some of these events in some of the videos in the description. But something very unusual happened on the 6th of February 2025. Something nobody expected, and something we still have trouble explaining. This was initially reported by Fabian Schussler on one of the astronomy forums, but you can also find the details in one of the links from the GRACE database, the database for various gravitational wave detectors. This is actually created automatically. Now at first, this didn't really look unusual. It appeared as a typical gravitational wave coming from a distance of over 1.1 billion light-years away from us. And based on the signal, this was determined to be potentially a neutron star black hole collision, maybe a binary neutron star, or maybe there's a slight chance that this was just a terrestrial signal. And so here, whatever collided had an overall much lower mass. No more than 5 solar masses. Actually, quite likely, much lower. But completely independently of this, within just a few minutes of this event, there was actually an unusual alert from something entirely different. Here there was an alert from the Ice Cube Neutrino Observatory in Antarctica, an enormous facility whose schematic you see right here that uses thousands of these unusual digital optical modules to detect neutrinos. We've discussed this facility in one of the videos in the description, and you can basically learn about how it operates. And it turns out that there was a detection of neutrinos coming from this location within approximately 5 minutes after the initial gravitational waves have passed. Which makes this a super exciting event because this is the first time ever we've actually connected physical particles, in this case neutrinos, to a space-time disturbance such as a gravitational wave. This has never been seen before, and this is sort of groundbreaking for cosmology. And so the obvious question here would be, okay, so what exactly happened, and what produced these neutrinos, and of course, the gravitational waves? Now right now we don't really know, and it's actually too early to tell, but here a lot of these questions could be resolved if we also detected some kind of an electromagnetic wave or some kind of an emission in other frequencies. And guess what? 2 days after this initial detection, something else was discovered in some of the other data from a completely different telescope. And this is where things get super exciting for astronomers and a lot of cosmologists. Turns out there was also potentially a fast radio burst, detected by a Canadian telescope specifically designed to study fast radio bursts. This is a facility known as Canadian Hydrogen Intensity Mapping Experiment, also known as CHIME, that's been exceptionally successful at discovering a lot of different FRBs. Now, if you've never heard of FRBs before, it's one of the biggest mysteries in astronomy right now, and once again, some of the videos in the description talk about this a little bit more. And well, it turns out that this event potentially also produced an FRB. This too was detected around the same time frame, possibly about 50 seconds after gravitational waves, and this too seems to have come from the same location. The chance for these three events to be basically separate events, all coming from the same spot in the night skies, is extremely low. So right now, the neutrinos, the FRB, and the gravitational waves are believed to be the same event. And though once again not much is known about this event yet, since FRBs have previously been connected to neutron stars, and specifically magnetars, here this might be one of the potential hints to what actually happened. This could have been a collision involving some kind of a magnetar or a neutron star with extremely powerful magnetic fields. But obviously only time will tell because right now there is really no studies, no analysis and no explanations yet, and everything for now at least is just a speculation. Either way though, whatever happened here is now officially one of the most important gravitational wave detections in the last 10 years. And not only because we detected neutrinos, also because we detected an FRB. Which essentially means we might finally have a chance to solve several mysteries at once and discover a little bit more about the universe in the process. It will definitely take some time to actually analyze all of this and to provide conclusive evidence to what exactly happened here, but this is one of the most important multi-messenger events, just as important as that kilonova from 2017, but possibly even more important because of that fast radio burst. But I guess what's really interesting is that even now we have absolutely no idea what happened here. I mean, for all we know, maybe this was just some kind of a bizarre event on top of a magnetar, as predicted by some of the other studies involving magnetars basically having these major star quakes, or maybe this was some kind of a completely new event we never even knew existed. Which naturally means we'll come back and discuss this more in some of the future videos once we have some answers or some definitive explanations. And so yeah, in just the last 10 years, this field of gravitational wave detections has advanced so much and helped us understand the universe in ways we could never imagine. As a matter of fact, in just the last few months, there's even been more propositions on how we can potentially detect gravitational waves by even using minute deviations in the magnetic field of planet Earth, because as gravitational waves pass through planet Earth, they actually do produce very small deviations in this field that end up producing very specific radio emissions, something that in theory could help us detect even more of these waves, helping us uncover even more mysteries. And then we of course have LISA, the enormous gravitational wave detector that's going to be operational in 2035, that's going to be orbiting the solar system and will help us uncover so much more. And looks like once again we have some kind of a bizarre, unexplained discovery coming from somewhere out there in our galaxy. A new, unusual object we've never seen before, and an object that currently is basically impossible to explain. And you're kind of seeing it right here. A bizarre, icy object somewhere in our galaxy that doesn't resemble anything we've seen before, and nobody can currently explain what we're even looking at. And so let's discuss this discovery from the Japanese astronomers in more detail, starting with how this was found and what the scientists have recently uncovered by doing a follow-up study and by conducting additional observations. You're probably aware that US and Europe are not the only countries launching various space satellites, and Japan has actually been doing a pretty good job at this as well. And back in 2006, they launched Akari. This was a Japanese space telescope, sort of I guess similar to a kind of a baby James Webb Space Telescope, that for approximately 5 years scanned the night skies in infrared frequencies. And during its operation, it basically observed the entire night skies until the unfortunate electrical failure in 2011. And in 2023, or approximately a year and a half from when I'm making this video, it re-entered atmosphere and crashed into our planet. This picture from Joseph Remy shows us the approximate position. And during its operation, it did actually make a few intriguing discoveries. For example, first ever infrared detections of a supernova in Small Magellanic Cloud, various molecular clouds around active galactic nuclei and large black holes, lots of different star-forming regions in our galaxy and outside of the galaxy, but also a few objects that were kind of unusual and somewhat difficult to understand. And two of these objects basically kind of looked like this. This was from our own galaxy. And even though these objects appeared to be very close to each other, they were actually separated by a relatively large distance. In other words, they appear to be kind of unrelated to one another. And here we're talking about distances in tens of thousands of light years away from planet Earth, basically almost on the other side of the galaxy. But unfortunately, this telescope was not powerful enough to tell us exactly what this is and to separate wavelengths of light in order to provide details of composition. And so for basically almost 2 decades now, a lot of these objects remain kind of mysterious and practically forgotten. But in this recent study, the Niigata University researchers, whose names you see right here, decided to finally conduct a follow-up using modern telescopes such as ALMA. And this is where essentially the mystery kind of starts, because it looked like nothing we've seen before. It appeared to be either some kind of a really dense gas cloud, maybe some kind of a young star, or maybe something else entirely, but it also appeared to be essentially some kind of an icy object with something relatively bright and something relatively hot in the center. And so right now they're just called peculiar embedded icy objects. Peyo, I guess. But the more surprising fact is that there seem to be 2 of them in a very similar location in the night skies, but really far away from each other. So this is not just some kind of a single phenomenon. And the fact that they don't look like anything we've seen before is really why this is probably one of the most exciting discoveries in the last few years. But we obviously have some details based on ALMA observations. For example, first, these 2 objects seem to resemble each other, and they're also very small compared to a typical gas cloud. So these are not nebula, these are not molecular clouds, these are not your typical clouds that usually result in new stars. As a matter of fact, in terms of size, they seem to be about the same size as a typical star system, or maybe just a little bit larger. But their composition is very strange. It's basically mostly ice. Here scientists discovered a lot of carbon monoxide, a lot of silicon monoxide, and yeah, ice everywhere. Which is pretty bizarre because we would expect something like, for example, maybe more hydrogen, or maybe even water, somewhere in these observations. Instead, we seem to see a lot of silicon, and actually way more than carbon, which is very often associated with some kind of a really powerful cosmic explosion. For example, some kind of a young star producing all of this material, emitting it into outer space. But here this would not really make sense because these are really small objects, and a typical star that would produce this, such as a Wolf-Rayet star, is way larger. On top of this, these objects are quite isolated. They don't seem to have any neighbors or other clouds near them, which means that these are unlikely to be new stars. They're also unlikely to be just parts of some kind of a larger cloud, and unlikely to be stars escaping a typical star nursery. And so here we have something relatively small, very isolated, enriched in a lot of different ices whose origin is a little bit questionable, and more importantly, combining all of these features and observations together, we get an object we've never seen before, with the biggest contradiction being the fact that they seem to be cold, they seem to have lots of ice, yet they still seem to emit a lot of infrared light right from the center, kind of resembling a typical hot star. As a matter of fact, in terms of luminosity, both objects are estimated to be anywhere from 500 to 750 times brighter than the sun. So yeah, these objects also seem to shine. And since there are no clouds near them and no source of any kind of ice in this vicinity, it's basically unknown where they even came from. These objects are truly isolated and relatively compact. Additional observations also reveal that there is a relatively broad emission line, suggesting that something here is moving at 8 to 14 kilometers per second. So basically here gas seems to be orbiting something more massive in the center, in some sense maybe resembling a star system after all. These velocities are very common in a lot of different star systems. Or maybe this is some kind of a gas orbiting something central, which would imply some kind of a shock event that possibly happened in the past from something, I guess, exploding. But once again, since there are no nearby star-forming regions and no clouds of any kind, it's impossible to explain the origin of these two objects. In the study, researchers actually focus on two potential explanations. Maybe these are protostars, or basically baby stars, such as young stellar objects, and here the observations don't seem to resemble any of them. Likewise, maybe these are ancient stars or evolved stars, basically near the end of their transition, but once again, we cannot explain what's evolving into what, or even what sort of a star this would be, with the only possible explanation that the researchers provide at the end being some kind of a dust-enshrouded, oxygen-rich AGB star, or basically some kind of an enriched infrared star, that for some reason contains huge amounts of ice. And the additional explanation basically just being some kind of a coincidence, as in there is a cloud here, very small ice cloud, and maybe just maybe right behind this cloud, somewhere really far away, there is basically some kind of a bright star that's shining through this cloud, making it appear like it's the same object. The only problem with that explanation is that we have two objects doing this, and they both resemble each other quite a lot. So yeah, that would be quite a coincidence. And well, right now, this is pretty much where we're at. We have these two unknown icy objects, somewhat hot and bright on the inside, very, very cold and icy on the outside, that don't resemble any star, don't resemble any cloud, don't resemble absolutely anything. We don't have a name for them, we don't have any information about what this can possibly even be. These are just two icy balls, surprisingly in a similar location in the night skies, but separated by about 10,000 light years of space. And intriguingly enough, there's not even a single theory or explanation out there that can maybe start resolving this mystery. Normally when we find some kind of a mysterious object, there's at least one paper somewhere out there that might have predicted their existence. Here though, not so much. This is really a bizarre mystery. And actually a super exciting mystery because for all we know, we might have discovered a completely new kind of star. A star that for some reason has been never found before, has been kind of ignored I guess, but in this case because we have two, this might actually be it. An entirely new cosmic object, discovered completely by accident by analyzing older data. But in order to understand what's happening here, two things need to be done. The first, more obvious, is observations with the James Webb. James Webb was basically designed for these types of observations, and is going to tell us exactly what's happening inside by observing various molecules and by helping us understand how things are distributed inside this object, which could then allow us to maybe simulate the overall structure. And second, it's important to compare these two objects and to find individual differences, because this will also help us see what might have happened here and how these objects might have formed. Lastly, we need a wider survey trying to discover even more of these objects somewhere out there, because chances are this is a new type of a star, and chances are they're actually everywhere, but for some reason were never seen before, maybe because people didn't actually think this would be a new star or a new object. And that's because previous infrared surveys never really looked that far and never really had enough resolution to identify such small objects at such distances. Now though, with the James Webb, once we have a hint of one of these objects again, it will be possible to determine exactly what's inside. And right now the scientists behind the study applied for James Webb observations in order to essentially try to solve this mystery. Which means that in the next few months, hopefully, we'll hear back more about this and maybe have our first answers. Right now, I'm just going to leave this at a very big question mark. No idea what this is, what created this, how old this is, or even if it's some kind of a cloud, planet, star, weird cosmic snowball, or obviously, aliens. Which it probably isn't, but still. And it's time to talk about FRBs, or fast radio bursts, once again. Mostly because in just the last 2 months, there's been some more updates and some more somewhat intriguing discoveries, potentially once and for all pinpointing one major source of many of the FRBs, solving the mystery of some of them. And so let's talk about these discoveries in more detail, and I guess let's start with one of the more recent studies that just came out. The study by Ines Pastor Marzuela and Jory van Leeuwen and the team from Netherlands. And here, by using the Westerbork Synthesis Radio Telescope, also known as WSRT, a very powerful telescope that contains 14 really large steerable antennae, researchers were able to discover over a dozen more FRBs, but more importantly, measured some of the properties in such a way that it actually allowed us to figure out what exactly potentially produced these bizarre radio emissions. But to understand this discovery, let's briefly go through the summary of previous discoveries and what we know so far. So most FRBs, most fast radio bursts discovered, all come from very distant galaxies. And though for every individual galaxy a typical fast radio burst would be kind of rare, because so many galaxies produce them, we actually see a lot of FRBs every single day. And prior to their discovery in 2007, which was actually done completely by accident, some of the most powerful radio emissions always came from pulsars, from neutron stars. And these can be visible up to 100,000 light years away, and sometimes even a little bit farther. But for the Milky Way galaxy, when it comes to fast radio bursts, so far there's only been one detection. This happened in 2020, and the video in the description talks about this more, but this location, SGR 1935 plus 2154, has been officially confirmed to host a neutron star, and actually to be more specific, a magnetar, and has now produced one FRB. Not very powerful, but an FRB nevertheless. And this was the first evidence we had that most of the FRBs extremely likely come from neutron stars. But understanding their origin is a completely different story. As a matter of fact, in modern astronomy, it's one of the main stories and one of the main scientific mysteries. And so in this recent detection of confirmed 18 FRBs, they actually all seem to show very specific properties of polarization and burst that we often observe in very similar objects such as pulsars and nearby magnetars. With just one exception: they're way brighter, or way more powerful. But they also all contain just a little bit of scattering, very likely produced by something around these objects, with that something potentially being a lot of gas. But every one of these FRBs was also slightly different from one another, which essentially suggests that whatever the source is, it seems to be embedded in different types of media and different types of, gas and different types of nebula, which makes them slightly different, produces slightly different frequencies and slightly different scattering, and would basically imply some kind of a nebular origin with something very powerful like a neutron star in the center. Which is exactly what we usually see in pulsar and magnetar systems as well, but once again with a lot less power. But intriguingly, around the same time, there was actually another really important study that discovered something very similar, but in a completely different way. Here they used something known as scintillation. And so in this study by Kenzie Nemo and his team, researchers took a slightly different approach. And it's the approach that we're all actually taught as kids when looking at the night skies in order to figure out if what we're looking at is a star or a planet. Now you might have already forgotten this, but back in the days I think most of us are told that if something is twinkling, twinkle twinkle little star, it is a star. Whereas if something is more or less stable and doesn't change much, it has to be a planet. So basically, a classic way of telling a star from a planet apart is that stars twinkle, planets don't. And that's because the light from both passes through our atmosphere. But because planets are actually a little bit bigger in size and technically appear as tiny disks, they don't flicker and their light appears more or less stable. This is based on the principle of light dispersion as it passes through the atmosphere. But for many different stars, especially really far away ones, because they appear as tiny dots, and the source in this case is a tiny dot, it starts to flicker, suggesting that the apparent size of the light source is actually the key factor when it comes to scintillation. And here an extremely similar principle can then be applied to very distant objects with light coming from very far away. And so for this other study, researchers looked at the scintillation of these FRBs as the radio waves traveling away from them move through various gas inside galaxies and through various interstellar medium. And in this case, if the object it's coming from is really small and very distant, we actually expect more scintillation or more twinkling, except that in this case it appears as radio twinkling or radio scintillation. And based on the analysis of a repeated FRB known as 2022-1022A, the FRB detected in 2022, researchers were able to constrain the overall size of this object, or the source of the FRB, providing very important evidence that the emissions in this case have to come from some kind of a magnetosphere or an extremely compact region of a very compact object. Or just to rephrase this, the only way this scintillation or this twinkling could be produced is only if it came from a very compact point within about 10,000 kilometers of a highly magnetized source. So that's basically smaller than planet Earth. And so this FRB has to have come from a super magnetized region, with the only object that's able to produce anything like this being magnetar. So in this case, this study definitively confirms that at least one of these FRBs also came from a magnetar, just like in the Milky Way. And though some of the previous studies suggested that maybe this is actually created by something much farther away from the object, and is possibly the result of some kind of a shock wave or a massive cloud really far from the star, here this observation confirms that it has to come from the magnetic environment of an extremely compact object, and also very close to the source, which means that a lot of these FRBs are potentially generated right above the surface of the magnetar through some somewhat mysterious means. The actual process of production is still not understood, but there's at least one previous video that goes through some hypothetical scenarios. One of them involves swallowing a planet. But intriguingly, once again, around the same time, there was actually another study that potentially created a bit of a problem for a lot of these explanations. And here this was a study that focused on trying to figure out where exactly a lot of these FRBs came from. So for example, by looking at something inside the galactic arm, like in some of the previous detections you see right here, it might be the result of a magnetar once again, because magnetars, in a nutshell, are just extremely young neutron stars. Neutron stars that are usually a few hundred or a few thousand years old that will eventually quiet down and become something else. We do expect these objects in very active star-forming regions and in various galactic arms. But it looks like, according to the new study, not all FRBs come from regions where young stars could exist. And so in a study we briefly discussed previously, one of the FRBs was discovered in a very bizarre place. This was a study you see right here, and we've briefly talked about it last time, but here this was first of all a quiescent galaxy that was not producing new stars as fast, a galaxy about 2 billion light years away from planet Earth, also an extremely luminous and a very massive galaxy, actually the most massive galaxy to produce an FRB so far, but more importantly, as you can see from this image, it came from the halo of the galaxy, 130,000 light years away from the center. And in this region we don't expect a lot of young stars and actually expect a lot of ancient stars, for example inside globular clusters. Now in the Milky Way galaxy, inside a globular cluster, most stars are usually billions of years old, and so in these locations we don't really expect to find magnetars. But here we had an FRB 2024-0209A that already produced at least 21 additional pulses in 2024 alone, and is most likely going to be producing more this year. Which basically suggests that maybe not all FRBs come from these locations with young stars, and maybe not all FRBs are produced by magnetars. But that second proposition didn't really make a lot of sense, because here the emissions still resembled everything else, very magnetized, coming from a compact region, and so it did actually suggest a magnetar after all. And the question was, so okay, what can be possibly happening here? Over 100 FRBs so far have been proposed to have formed as a result of a magnetar. They all seem to have very similar emissions, but that requires a core collapse supernova. Essentially a massive young star going supernova, leaving behind a neutron star which then becomes a magnetar. But in the past there has been a proposition that magnetars might also form in different ways, and more importantly, in ways involving collisions. And so if this is some kind of a globular cluster containing ancient stars, it might also contain a lot of white dwarfs, just like in clusters around the Milky Way. And if there's a merger between two white dwarfs, or a white dwarf and a neutron star, according to at least one study we've discussed previously, there is actually a chance it might turn into a magnetar as well. That video in the description talks about this a little bit more, but chances are that a lot of magnetars are formed in a very similar way, and colliding white dwarfs, in some sense, could also be some of the biggest sources for these bizarre radio emissions. And intriguingly, something very similar was also found around this galaxy, Massey 81, just 2 years ago. A very similar fast radio burst coming from a region that's outside of the galaxy, with extremely similar emissions, suggesting a magnetar. So basically these new discoveries potentially suggest that some magnetars form in ways we never imagined, or I guess more accurately, point at the fact that we have no idea how magnetars really form. We just know that they exist, we know they're very powerful and contain ridiculous magnetic fields, and we know that they seem to be responsible for fast radio bursts, at least most of them. But because this is still an active mystery, and a mystery that does not have a final conclusion yet, more observations are required in order to find more evidence and in order to have even more explanations. And so at least for now, as of January, February of 2025, FRBs are still a mystery. And today we're going to discuss a recent announcement in regards to what seems to be an extremely powerful neutrino that was recently detected by a very cool facility located in the oceans in Mediterranean just off the coast of Sicily. A facility that was designed specifically to detect such events. But in this case, because this neutrino currently makes absolutely no sense, it's sort of worth talking about because it is extremely unusual and seems to have come from some unknown powerful source. And so let's talk about this in more detail, but I guess let's briefly start with exactly what neutrinos are and how this facility works as well. And while even today neutrinos are still some of the most mysterious particles known to us. These are essentially elementary particles, kind of like electrons, protons, and neutrons, but in this case they contain no charge, and also we don't really know what their mass is either. It seems to be extremely tiny, with some scientists even suggesting that they might have no mass, but that's actually because we basically know so little about them. As a matter of fact, today neutrinos are also seen as one of the potential explanations for the mysterious dark matter, mostly because we know there are a lot of them out there, and also because they don't really interact with stuff very easily. When it comes to matter, the only interaction they produce is either through gravity or through what's known as the weak force, whereas the majority of other particles known to us usually interact through the strong force as well. In more layman terms, it just means that they can basically pass through pretty much anything, even going through the entire planet, completely unhinged. But because they can interact through the weak force, which they do sometimes, occasionally we detect their presence when various collisions create additional particles. And even though you might not think about neutrinos in your daily lives, they certainly think about you. As a matter of fact, every single second as you're watching this video, billions and billions of these particles are going through your body without you noticing every single second. But because they barely interact with anything ever, we don't feel any of it, and they don't really do much to our bodies. Which is why they're so difficult to detect, so difficult to study, and why we know so little about them. But there is a way to study them, and in the last few decades researchers found quite a few different techniques. And so even though neutrino astronomy is still in its infancy, we've already confirmed several neutrino sources. The most famous one was the supernova from the Large Magellanic Cloud that you see right here. This event is known as SN 1987A. On top of this, we also know the Sun produces quite a lot, and many have been discovered coming from the Sun. But we also know that stuff on Earth can produce neutrinos too. Here's a map of what's known as geoneutrinos. These are from natural sources like uranium and thorium, but also from various man-made reactors, specifically nuclear reactors. Although in this case, scientists did not measure this directly, they actually used radiogenic maps in order to estimate the amount of neutrinos produced on the planet. And that's because, once again, trying to study neutrinos and trying to catch them is super challenging. But today we know of at least 3 main ways. And they usually involve a lot of liquid, mostly water, and detectors able to perceive extremely tiny emissions of light. In this case, these detectors are usually built either underwater, like the one you see right here known as Antares, or somewhere inside the mountains, like some of the Japanese experiments, with the famous one known as Super Kamiokande, or, like in the case of the biggest detector ever, under ice. The Ice Cube Neutrino Detector is a huge facility built entirely in Antarctica. And in many cases, they basically function the same way. Here the expectation is that, once in a while, one of these trillions and trillions of neutrinos is going to interact with something as it passes through all of this water. Because this happens extremely rarely, here, the larger the size of this detector, the more likely we're to find something. And because there are thousands of individual detectors, they can then also create a kind of a three-dimensional map, even tracing the vector of neutrinos, figuring out where they came from. And this was actually used recently in detecting one of the most incredible gravitational waves and its potential source. You can learn about this in one of the videos in the description. And so after several detections, we know that neutrinos seem to come from many different sources. Actually, quite a lot of them were probably created during the Big Bang, but a lot of other neutrinos seem to come from super powerful sources, usually massive black holes, but also very powerful supernova. And even though this is a young field, we already have a network of these facilities basically interacting with each other and sharing data. We have Antares, Baikal, IceCube, P1, RNOG, and the one we're discussing today, KM3NET, which stands for Cubic Kilometer Neutrino Telescope. This is a European facility that's still actually under development, but it's already functioning and it's already collecting data. And here once again it uses these digital optical modules. Their only purpose is to basically detect photons. And just like with a lot of other facilities, here they're placed deep in the water. Actually, very deep. 3.5 kilometers in depth, somewhere near the coast of Sicily. Actually, the curiosity got the best of me, and I wanted to find out exactly where. And it's basically right here, in an extremely deep groove that was actually surprisingly mentioned in one of the previous videos, because this is also how the Mediterranean was refilled approximately 5.3 million years ago, when Earth experienced one of the biggest floods on the planet. You can actually learn about why this area is so deep and what's happening here in one of the videos in the description. But this is where this facility is located. And in February of 2023, it seems to have discovered something really bizarre. Something we've never seen before. A record-breaking neutrino. Hundreds of times more powerful than anything we've seen before. Here this is known as the ARCA detector, and the data from this detector that was analyzed in recent studies has now been confirmed to be absolutely ridiculous. In terms of a number, it seems to be about 220 peta-electron volts, which is way more powerful than anything ever seen coming from any object. Actually, I had to do a bit of a search to discover the next record holder, and it seems to be in this study from 2022, where the 10-year-long observations from the IceCube revealed at least one event that was maybe 25 times less powerful. Something like 5 to maybe 10 peta-electron volts. And here this was essentially detected by seeing approximately 28,000 photons produced by neutrino's passage, which when traced produced another unusual mystery. It was practically horizontal. Okay, you can actually ignore the Eiffel Tower here, this is just for size reference, but it was basically passing underwater at just 0.6 degrees in terms of inclination, which actually suggested that it very likely passed through the ocean and planet Earth before being detected by this facility. In other words, it very likely passed through rock, through a lot of water, and large chunks of Earth's crust before it finally hit at least one atom visible to KM3NET. Here's roughly what the pathway potentially looked like. And this is of course also strange, but kind of expected of neutrinos. It once again shows you that they don't like to interact with anything. Yet this neutrino decided to interact with that one atom very close to this telescope. And so the obvious next question was, okay, so what caused this? What could be so powerful? And where is this all coming from? Now, in one of the previous videos I mentioned before, we've talked about neutrino detection coming from either some kind of a very powerful neutron star supernova, or possibly some kind of an unusual event around a magnetar, where neutrinos were produced, but were not that powerful at all. As a matter of fact, some of the most powerful neutrinos we've seen so far mostly came from this source right here, TXS 0506 plus 056. This is a very well-known blazar, a ridiculously powerful supermassive black hole whose jet is pointed almost directly at us. This is a very well-known source of gamma rays, a powerful source of neutrinos, and it's already been studied for many years. But this neutrino did not come from this region at all, and it was way more powerful. Which basically takes us back to the original question, what caused it? Well, right now obviously there are only ideas and different propositions, nothing concrete yet. For example, this could be a Milky Way source, basically inside our galaxy, but we don't really know of anything in our galaxy in this particular direction. A more likely explanation is outside of the galaxy, and very likely coming from some kind of a distant galaxy, mostly because nothing else seems to have come from this region, and no additional detections of gamma rays or anything else was discovered so far. And so here, based on the location, researchers discovered at least 12 potential targets, which are very likely blazars too. But right now, none of them specifically seem to stand out, and none of them are exactly in the same spot. And so the blazar explanation, though possible, is still not the best. So essentially, if this is coming from some kind of a supermassive black hole, we don't really seem to see anything in this exact spot. Or the one explanation here might be that it's just really far and we're not seeing it, but here, unless we see it, it's going to be impossible to prove. However, there's maybe another possibility. This could be what's known as a cosmogenic neutrino, or basically a very high energy particle that's actually created when cosmic rays interact with the cosmic microwave background. Now, if this is indeed a result of a super powerful cosmic ray producing neutrino as a result of the CMB interaction, this will be the first case of this detection ever. And even though theoretically scientists think it's possible, the chance of it happening is extremely low. Which essentially leaves us with this mystery. We definitely know something really powerful created this. We also have never seen anything like this before. And right now, out of all explanations, nothing really sticks. Whatever created this, it was very likely an extremely powerful cosmic accelerator that was able to send super powerful particles, possibly for billions and billions of light years. But unless we see something else in different wavelengths, it's going to be extremely difficult to explain this just because of how powerful this event was. And though the chance of this coming from a blazar is still actually pretty high, without further evidence we're not going to know for sure. And that means that we have another mystery to discuss in some of the future videos once there is some more information. And in this video, we're going to discuss some of the recent discoveries coming out of incredible radio telescopes in Australia and in South Africa that essentially present us with a lot of somewhat bizarre and somewhat mysterious circular discoveries. In other words, various radio circles. Some kind of expected, and some somewhat easy to explain, but some really strange ones, like this almost perfect circle that was recently discovered in one of the surveys, and some connected to a very big mystery referred to as ORCs, odd radio circles. Very strange massive formations discovered in certain locations that we now potentially can explain. And so let's discuss this in a little bit more detail, but first let's start with how this was discovered and why studying this is kind of important. And well, in essence, this is a combination of two major telescopes. ASCAP, also known as the Australian Square Kilometre Array Pathfinder, located in Western Australia, and Meerkat Radio Telescope, located in South Africa. Two extremely powerful radio facilities capable of seeing the universe in pure radio frequencies, or essentially revealing the universe in a way we've never seen it before. Mostly because both of these telescopes are extremely sensitive and helped us reveal very dim objects that were previously completely invisible. Although here I guess it's also important to understand exactly what we're talking about when we talk about radio frequencies and radio universe. There's a link in the description that helps you visualize all of this, but this is a website known as Glimoscope. And well, in essence, if you have any optical telescope, by looking at the night skies you're going to see something like this. But as you might be aware, we have several telescopes, including space telescopes, that focus on very different frequencies. For example, for an X-ray telescope, the view will change completely. And for a gamma ray telescope, everything looks entirely different as well. Not so long ago, we've actually discussed one of the biggest gamma ray maps ever created that was only released a few months back. I think there's a video in the description discussing this more. Then we have the infrared. This is the domain of telescopes like WISE or the now famous James Webb Space Telescope. But the universe transforms dramatically once you start approaching much longer wavelengths such as microwave or radio light. And well, when it comes to radio frequencies, things become extremely different. Because in many cases, a lot of radio sources contain very unique physical properties and physical features that cannot be seen in any other light. Now, one famous example I like to use is the nearby Centaurus A galaxy. Here's what this galaxy looks like in radio light, but here's what this galaxy looks like in the optical light. It's practically invisible. But here's what it looks like if you combine all of the frequencies into one single image. And so despite this image being really famous, it's actually not something our eyes can see at all. This is a combination of radio light, optical, infrared, and even X-rays. But when it comes to radio frequencies, a lot of these telescopes have been participating in various surveys in order to basically map the entire universe to help us understand what's going on out there. And once again, because we just don't really see the same objects with the radio light compared to everything else. With one of these very large surveys known as EMU, Evolutionary Map of the Universe. A really large program whose main purpose is to map the entire southern sky in order to create the biggest possible radio map we've ever seen of the entire southern hemisphere. And so many of these new discoveries actually come from this survey, with many of them from different locations and at different distances. And so in one of the recent articles you can find in the description, scientists discuss some of these unusual circular formations because they seem to be ubiquitous, they seem to be pretty much everywhere, but they all come in different sizes and obviously at different distances. And here's one such study discussing a never-before-seen ring-like object from right here in the Milky Way, currently referred to as Kuklos. You can actually see this object right here on the left, and though at first it wasn't clear what this was, it turned out to be a star that one day will go supernova. And so this somewhat strange radio ring that does resemble a lot of other radio circles, actually seems to be right here in the Milky Way galaxy, because it also seems to contain a lot of different features we usually detect around Wolf-Rayet stars. Some of the most massive and some of the brightest stars in the entire universe that are extremely close to going supernova, mostly because they're now so unstable that they're throwing out huge amounts of gas as they enter the final stages of their life cycle. And we usually detect a lot of nebula around these objects, and they're usually bright enough and powerful enough to be visible from a different galaxy too. Here's one in the Large Magellanic Clouds. But as you can see, they also generally form circular features, which in this case are visible in both of these objects. K-Close and WR16 both form relatively large radio circles in the night skies. And one of the main reasons we see them is because a lot of gas escaping these stars has now basically cleared the environment around the stars, forming these circular symmetrical objects. But surprisingly, they actually look very similar to something entirely different, in this case supernova. Because a lot of supernova are also kind of circular and will very often possess very similar shapes. And so in some cases these radio circles can also be formed by various star remnants, but in many cases they will usually contain some kind of a deformation. And in this case it's because sometimes there's just a bunch of gas around these stars, and so when the supernova happens and the gas from the star starts to explode away from the center, one of its sides can occasionally slam into interstellar gas, producing additional radio emissions. And so quite a lot of them basically look kind of like this. But in some rare cases, if there's no interstellar gas around the supernova, we can actually end up with some super bizarre objects. And that's basically what you see right here. This is an object now referred to as teleios, which is Greek for perfect. An almost perfectly circular shape that, though very surprising at first, did turn out to be a supernova remnant once again, but was strangely enough invisible in other wavelengths. In other words, we now know it's a remnant, but it was originally discovered by looking at radio light. But in some other cases, a supernova can also happen in an extremely turbulent region, and at the same time can also be extremely large, probably because the explosion was very powerful, which is where we get this object. Now, because this was discovered by ASCAP, it once again has a somewhat strange Australian name, but here it's now referred to as Diprotodon, or I guess Diprotodon supernova. This is the largest supernova remnant ever seen, and in this case, if we could see this object, as in we could see it with our own eyes, it would be 6 times larger than the Moon, but once again only visible in radio light. You can learn more about this object in one of the studies in the description, but in essence this recent study confirms the distance and confirms that this object is way larger than we ever thought. It's approximately 500 light years across, so definitely something that goes beyond our expectations, with some of the other circular objects visible in the Milky Way being various types of nebula. For example, VDB-80 is essentially what's known as a reflection nebula. It actually looks like this in the optical light, but because certain types of gas, such as ionized hydrogen, tends to produce certain radio emissions, some of the light from various stars can also push the hydrogen, forming a kind of a circular shape, which is what happens here with this object now referred to as Legotis, once again named after an Australian animal. But in most cases, these circles in the Milky Way are not actually that difficult to explain. Yet we do sometimes find circles that appear to be much farther away, and thus seem to be the result of different galaxies. And while one type of new galaxies discovered by ASCAP and Meerkat are known as radio ring galaxies, a bizarre type of galaxies that seem to contain a hole in the middle, but only when seen in radio light. If you look at these objects in optical light, they normally appear as normal disk galaxies and don't actually appear to have anything different. And so what exactly happened here? Well, right now the only explanation we have is that once upon a time there must have been some kind of a superactive period with maybe a lot of supernova exploding around the same time that created so much force that a lot of gas from this galaxy was basically pushed to the outskirts, forming a ring with an empty circle in the middle. Or at least that's one of the explanations we have for now. This is a new discovery, so there is still a lot of uncertainty. And then we come to the most mysterious circle of them all, Orc. This is the odd radio circle. You can actually learn more about these in some of the videos in the description, but this is basically a type of an object only discovered 5 years ago, and that even now doesn't actually have a very good explanation. Because in many cases, these radio circles only sometimes have something in the middle, usually some kind of a galaxy, but sometimes have nothing in the middle. But more importantly, in most cases, these are the largest circles out there, hundreds of thousands if not millions of light years across. and though the explanation for some of them involves some kind of a major emission from some kind of a galaxy out there, this doesn't obviously apply to all of them, because there is not always a galaxy in the middle. But one of the main reasons they're so difficult to explain is really because they seem to be only visible in radio light. A lot of other objects like the supernova remnants or the nebula, they are visible in additional frequencies. Here though, there seems to be nothing else. No optical emissions, no X-rays, no infrared, nothing. And so even if this is some kind of a galactic explosion, it's difficult to explain that we're seeing nothing else. As a matter of fact, a few months back, there was another one discovered that you can see right here. And once again, super difficult to explain. But using simulations and various theoretical models, scientists believe that there might be one way to explain all of them, assuming we can prove there is some kind of a radio galaxy nearby. And here we're talking about a galaxy like this. A galaxy that's able to produce enormous radio jets, very often stretching for over a million of light years away from the central black hole. And the explanation here focuses on the perspective. Or in other words, what if there is a radio galaxy somewhere out there, but it's essentially shooting these jets at us, kind of like a quasar or a blazar, but we only see radio light as a result. And to prove this point, researchers conducted additional simulations, trying to see if they can maybe create something similar by using a modeling software. And strangely enough, they were able to recreate at least two of these objects with extremely similar features, with the main explanation basically being a lot of fast-moving particles smashing into intergalactic gas that produce electrons and positrons, which emit radio light visible right here. And so by seeing these jets almost face-on, they might appear as these very bright radio circles. And more importantly, the predicted bubbles here seem to appear just as big as the real ones. Here the size is over 1 million light years across. But then there's, I guess, one question. Why are we only seeing a handful and not more of them? Because radio galaxies are actually pretty common, and at least some of them should be pointing their jets directly at us. And while there's maybe one explanation coming from the study, there seems to be some kind of a critical factor involving the amount of gas around this galaxy. If a radio galaxy is located in a somewhat dense region containing a lot of intercluster gas, the jet might be blocked completely. But in a cluster containing low mass and also containing less gas, the jets might be easily visible, which is surprisingly why we seem to be seeing orcs in these low-mass clusters. And so essentially jets seem to be only visible when they're able to displace the gas located around the galaxy. But the study also predicts that, technically, we should be seeing some of this gas in the X-rays. In other words, these orcs should also be producing X-rays visible to various telescopes such as Chandra. But because it's not actually that bright, it would actually take up to 2 weeks to observe this, which just has not been done yet. And so in order to confirm this hypothesis, researchers just need to conduct additional X-ray observations to see if orcs also produce X-rays. And so until that's done, it's just going to remain a mystery and one of the most unexplored and unexplained astronomical questions of the last decade. But all in all, in just the last 5 years, so many incredible radio discoveries have been made by these telescopes, and so many new objects have been found that we never knew existed. And today we're going to discuss some of the new discoveries in regards to our own galaxy, the Milky Way, and actually in regards to a somewhat old mystery. The mystery that for the past few decades was referred to as the missing satellite problem. The problem of missing satellites. But in this case, satellites orbiting galaxies. And here we're of course talking about different types of smaller galaxies in orbit around the Milky Way. Although technically not all of them are in orbit, and some of them are just very close to us. But as the name suggests, for many decades there was a bit of a problem. Not enough of them were seen in the night skies, even though a lot more were expected. And so let's discuss some of these new studies and some of these new discoveries that basically create a bit of a different problem. And the problem now is practically the opposite of what it was 2 decades ago. Now the scientists discovered way too many satellites, and once again it's a bit difficult to explain. But first, okay, so what exactly do scientists mean by too many or too few satellites? I mean, who actually makes these rules about how many satellites a typical galaxy should have? Well, today most of these ideas are basically based on modeling. Not so much the observations, but instead various supercomputer simulations where various physical models try to predict what's going to form at the end. Here's actually the most famous one, TNG-50, created by the Illustris project. And here, in pretty much every single one of these models, when you put a bunch of gas and dark matter in similar conditions and similar gravity to what we have in the real universe, you basically end up with a bunch of galactic shapes. But around these shapes, as things start orbiting around and as galactic halos develop, we actually observe additional shapes. And so normally, in a typical galactic halo, we're actually going to also have tiny clouds of hydrogen and helium orbiting in much smaller subhalos, possibly 100 million to 1 billion stars in total, and basically resembling a typical dwarf galaxy, many of which have been discovered in the last decade. Now that by itself is not really a problem, as a matter of fact all of this has been confirmed, but it's really the numbers that seem to not match. In pretty much most of these simulations, when using the values for gravitational constant and the approximate amount of mysterious dark matter, which is supposed to represent 85% of all matter in the entire universe, all of these simulations ended up producing hundreds of different subhalos that would then turn into dwarf galaxies, which kind of initially did not make sense. It didn't make sense because by early 2000s, only approximately 10 dwarf galaxies have been discovered around the Milky Way, with this image right here kind of showing us what all of this looked like. And so something here was obviously not adding up. But this mystery started to be resolved pretty quickly once we got better telescopes. And also once the scientists realized that the galactic formation may actually not be as efficient as initially thought. And so in approximately a decade and a half, we went from having just these 10 dwarf galaxies to basically just over 60 confirmed as of early 2024. And this by itself kind of resolved some of these issues. And so even though hundreds of these galaxies were predicted initially, we now knew that at least 60 definitely existed around the Milky Way. This is at a distance of about 1.4 million light-years away from the galaxy, and as I mentioned, not all of them are in orbit. Some of them are passing by, but many of them will be swallowed over time. And only 2 of them are bright enough to be visible with the naked eye, the Large and Small Magellanic Clouds. But obviously this was still not a perfect resolution to this missing satellites problem. We had 60, but the scientists expected over 200. And so for the past 5 or so years, a lot of researchers out there tried to basically once and for all resolve this. And they did this by using even more advanced telescopes, and specifically the ones that are actually able to detect some of the dimmest objects in the entire universe. The telescopes such as the Subaru telescope, along with the Hubble telescope, that are able to find some of the faintest objects in the night skies. Here's actually another dwarf galaxy, known as Leo 4, even though technically there's really not much to see here. And so to conduct some of these recent studies, the researchers decided to do something really simple. They picked a relatively small area of the night skies, and then they used some of the most accurate data from the 7-year survey by the Subaru telescope to try to find these dwarf galaxies in it. And well, surprisingly, in a relatively small patch of the night sky, they've discovered 5 new, never-before-seen galaxies. You can see some of them right here, with the 3 previously discovered galaxies seen as triangles, and the 2 recently discovered, Sextant 2 and Virgo 3, visible as red and blue stars, with most of these approximately 500,000 light-years away from the Milky Way galaxy. And although at the first glance this might imply that we now have 65 dwarf galaxies around the Milky Way, in reality this actually creates a bit of a problem. A new problem, the excess satellite galaxy problem. And the reasoning here is really simple. As I mentioned previously, using simulations, the assumption here was that we should have approximately 220 satellites in the halo of the Milky Way galaxy, which means that on average, in a relatively similar point of space, we should maybe observe approximately 4 galaxies on average. Yet instead, the evidence from the Subaru telescope points at approximately 9 to 10 galaxies, implying that the Milky Way potentially hides 500 dwarf galaxies, with most of them completely hidden. Or basically there seems to be about 2 to 3 times discrepancy between the observations and what's predicted. And so this strange overabundance of galaxies basically now creates a completely opposite problem. Instead of not having enough galaxies before, scientists now realize that they were just difficult to see, and there seems to be way more than expected. Okay, but I guess that's just one galaxy, the Milky Way. Maybe something here is just a little bit weird, maybe once again the Milky Way, like in a lot of other cases, is just an exception, and so maybe this is not something to worry about yet. But then there was another study not so long ago that in essence discovered something very similar using a different observational survey, and this time in approximately 50 galaxies up to 150 million light years away from planet Earth. And though once again these simulations predicted 3 to maybe 4 galaxies, here they discovered up to 10. Or in other words, this survey could not possibly see those galaxies just because they don't produce enough light. Yet on average, around those galaxies, at least 10 dwarf galaxies were discovered. And that basically creates an entirely new problem that we cannot answer. Or obviously cannot answer yet. For some reason, it looks like galaxies surprisingly have way more satellites, not way less. Which to some extent is both ironic and funny, because the researchers were trying to solve the problem that was the opposite, and though they solved it, they now have an entirely new issue. And it's currently difficult to explain exactly what's happening. Now on the one hand, this is probably once again a problem with simulations. Like so many other scientists suggested, maybe this is actually because we don't really consider magnetic fields in a lot of these galactic simulations. Maybe by introducing powerful magnetic fields, which might have been much stronger in the early universe when these galaxies were super active, these primordial fields could have actually caused matter to clump much more, thus producing more satellites. And interestingly, if this prediction is correct, we should even start finding various dwarf galaxies with miniature satellites of their own, or basically even smaller satellite galaxies orbiting around them. This hasn't been discovered yet, but that's one of the predictions about these powerful primordial magnetic fields. Or maybe this is just a problem with simulations for some other reason. Obviously, maybe there's a problem with the gravitational constant, or maybe there's a problem with knowing how much dark matter there is, or how it actually interacts with galaxies. Likewise, it could also just be the problem with the overall resolution of these simulations, as we usually focus on much larger objects as opposed to tinier satellites. And so, in essence, it doesn't really mean that the cosmological model is broken or that the field of astrophysics is in trouble. It just suggests that there's something we don't understand, once again, and that something needs to be tweaked a little bit. But I guess more importantly, it also suggests that we once again need more observations, just like the ones that discovered these dwarf galaxies that we previously could not see before. But in a nutshell, this is also a really good example on how astronomy and astrophysics progresses over time. We went from this, a small number of satellites, and not knowing why there are so few of them out there, to something that looks closer to this, just last year, and to now having this, possibly times 10. And naturally, a completely new problem that nobody expected and nobody has an answer for yet. But because of these new mysteries and new discoveries, all of this will potentially lead to discoveries of completely new phenomena we never knew existed, and possibly help us explain a lot of other mysteries in the universe just by looking at what's happening in our neighborhood. And today, we're going to discuss some of the recent discoveries in regards to the earliest light in the universe, and specifically a completely new map that essentially presents us with the highest resolution available for the so-called cosmic microwave background, with the older map visible right here. And by itself, for cosmologists, this is actually a huge achievement and will most likely result in a lot of new studies coming out in the next few years that essentially try to assess the universe, and specifically the early universe, through these new extremely accurate observations now available to everyone. But at the same time, scientists have also discovered something somewhat surprising that we're going to be discussing in a few minutes. Although first, let's go through some of the history just so that you know what we're actually discussing. And here the story starts in 1965. Here the work by Arno Penzias and Robert Wilson involved this somewhat bizarre antenna known as the Holmdel horn antenna that completely by accident started to discover an unusual buzz that seemed to be occurring everywhere. And by the way, a few years back, this antenna was almost destroyed when someone tried to basically turn this land into some kind of a private condo. But a lot of people, including myself and subscribers of this channel, petitioned against it, and so far looks like we actually won. I mean, I'm not sure what's going to happen in the future, but this should not become a condo. Anyway, this discovery in 1965, though at first unusual, turned out to actually match a lot of predictions from several decades prior, which you can learn about in some of the videos in the description, that basically all confirmed the idea that we now refer to as the Big Bang Theory. And this was the biggest evidence. It essentially confirmed that billions of years ago, the universe was extremely hot and essentially opaque. But as it cooled down, once it reached a certain temperature, finally the light could get through, with everything essentially glowing in this extremely hot first light. But because this happened approximately 380,000 years following the Big Bang, as the light traveled across the universe, and as the universe expanded, this light cooled down, or in more scientific terms, increased in wavelength. And 13.8 billion years later, the wavelength stretched so much that it was now approximately 2 millimeters, which was equivalent to a temperature of about 2.7 Kelvin, or microwave radiation, which is roughly around 160 gigahertz. But despite this grandiose discovery, it actually took a couple of decades to finally come up with some of the first attempts to basically observe this in every single direction. And this was the first space-based mission. This was known as COBE, Cosmic Background Explorer, a satellite launched by NASA in 1989 that functioned for approximately 7 years. And during this time, it basically confirmed that this radiation seems to be everywhere, but it also seems to be just a little bit variable. Basically here it confirmed what the scientists refer to as large-scale anisotropies. But because the technology here was still being developed, the resolution was actually not very good. And so NASA followed this up with another satellite known as WMAP, which launched 5 years later in 2001. And it suddenly revealed the universe, or revealed this early light, with a lot more variability. Here it showed us a lot more temperature inhomogeneity, basically confirming a lot of previous assumptions and a lot of cosmological theories. It showed us the early gas all over the place, as it started to accumulate into thicker chunks and started to produce various overdensities. So basically it was not smooth, not uniform, and explained how the universe formed into what we know today. But as always, European Space Agency basically said, hold my beer, my probably Belgian beer. And just like with a lot of other space telescopes, like for example Gaia, it produced overwhelming results that surprised everyone. This was the famous Planck telescope, or specifically Planck Surveyor, launched in 2009, and after 4 years it produced the most accurate map we've ever had. The map that's basically been used in every single study ever since. But obviously this was not the end. As a matter of fact, several other missions have been actually conducted here on Earth by using even larger microwave detectors compared to the ones inside these probes. And as a matter of fact, the main advantage for these probes compared to an Earth-based telescope is that here these space-based observations were actually able to map absolutely everything. Whereas on Earth, even though we can produce higher resolution, generally you can only map approximately half the night skies, usually either the southern hemisphere or the northern hemisphere. And actually quite a few missions have been doing this for a very long time, with one major one finally releasing its first results. Now we're actually going to be discussing other missions, including the ones in Antarctica, and the future ones, including the ones in China, in videos later on, so make sure to subscribe if you want to learn more. But basically now, we finally get the most accurate data ever from the telescope known as ACT, Atacama Cosmological Telescope. And this telescope, as the name implies, is located in Chile, and was basically able to produce an incredible map with 5 times more resolution than ever before. The finest ever map of the cosmic microwave background. But once again, because this is on Earth, it only produced half of the map, so essentially only the southern hemisphere. And here it used this bizarre looking telescope that was built back in 2007 and received some of the major upgrades in 2013 and 2016. And though it's been conducting observations ever since, it was actually shut down in 2022 due to budget cuts in the National Science Foundation. Nevertheless, despite of this, it was still able to release all of its data, which you can essentially now explore by yourself in several studies in the description. Here, the observations by ACT provide incredible resolution, very high sensitivity, and most importantly, it's actually able to measure polarization directly. Or I guess to be more specific, the orientation of these light waves, which shows us how these waves evolved over time as they traveled across the universe. And here it's really the polarization that's most likely going to be leading to some of the major discoveries. And that's because the polarization in these images shows us a very detailed movement of hydrogen and helium during these first moments in the universe. Or in other words, in previous images from previous observations, we could only see where gas was as a kind of a still image. Here though, this polarization basically shows us how this gas is moving. So in some sense, you can actually imagine this as a moving picture, or I guess as a video, as opposed to just a still picture. And this movement is super important in order to show us how gravity used to pull things around and how everything interacted and assembled 380,000 years following the Big Bang. And as a result of these early observations, we already have some major conclusions, which, as I mentioned, were to some extent kind of surprising, but also a little bit disappointing. So here's what we have. At first, before this data was officially released, scientists were hoping to discover the anomalies that could potentially finally solve the mysterious Hubble tension or the bizarre observations with dark energy, and maybe even find clues for dark matter. In other words, they were actually hoping to find anomalies for the famous lambda CDM model, the model that currently describes the universe as we know it. And here maybe they could also discover the true age of the universe, or possibly deviations from the Hubble constant. Despite of this, these ridiculously accurate observations, instead of contradicting anything, seem to have actually confirmed all of it. The lambda CDM model was confirmed with extreme accuracy, as was the Hubble constant and the age of the universe. In other words, the surprise here, or I guess the disappointment here, was that it provided absolutely no clues to a lot of these cosmic mysteries we've discussed in some of the previous videos, and in a video that should be coming out really soon about the mysteries of dark energy. And this was actually from a completely different observation based on the nearby universe using the instrument known as DESI. The link about this should be in the description. And so here the Hubble constant was confirmed to be about 68 km per second per megaparsec. The universe was confirmed to be 13.8 billion years old, and more importantly, it dramatically increased the precision, implying that previous observations were extremely accurate too. And though a lot of scientists were hoping or expecting to see something that was going to be a little bit different, and possibly something that would have been previously invisible, instead, literally everything observed was exactly how it was in predictions from over 10 years ago. Absolutely no unexplained phenomena in these observations, and no solution to the Hubble tension or to the mysteries of dark energy. But this is also a really important discovery, because here this is a confirmation that the early universe is not really responsible for a lot of these problems we're seeing today, including the unusual deviations in dark energy and even bizarre mysteries of dark matter. Here this kind of confirms that the early universe was really kind of simple and explainable with previous models, which actually rules out a lot of different theories and propositions that try to provide alternative explanations. Basically here, lambda CDM, at least for now, seems to prevail. But I guess here let's also briefly discuss exactly what the scientists think we're looking at and what you're actually seeing. First of all, this is an enormous image. Here you're actually looking at something 50 billion light years away from us, or basically a kind of a sphere 50 billion light years in radius. So technically this is an enormous object. But because of the accuracy of these images, we can now even see individual galaxies and individual objects as slight overdensities in a lot of parts of this image. But because most of the things we're seeing is basically just gas and essentially just pure energy, technically we're seeing something equivalent to 1900 zeta suns or zeta solar masses of mass and energy. Although physically we can actually only detect only a small percentage. Basically here approximately a quarter or 500 zeta suns is the mysterious dark matter, about 1300 is the mysterious dark energy or vacuum energy, and only about 100 is the matter that we're made out of. But in terms of these patches, what you're actually mostly seeing is hydrogen and helium. 3/4 is hydrogen, 1/4 is helium, with an extremely small amount being neutrinos, which are invisible. And intriguingly, helium was actually produced along with hydrogen in the first 3 minutes of the existence of the universe, whereas all of the other stuff is actually not visible here yet, because things like carbon and oxygen were not created yet. This will form millions of years later as a result of various supernovae. And so every one of these dense regions is essentially hydrogen-helium clouds millions of light years across, and eventually this will form various galaxies. And so here, by observing these super precise images, scientists have also confirmed something else super important. The overall expansion of the universe, based on the apparent size of these ripples inside these images, seems to indeed confirm the universe is 13.8 billion years old, with the uncertainty of only 0.1%. And so a lot of alternative explanations that try to explain the universe that's 26 billion years old or even older seem to be almost definitively incorrect. At least they would not be able to explain these recent observations of the oldest light in the universe. But because this has just been released, we don't really have a lot of other discoveries or a lot of additional studies yet. And more importantly, we only have half the hemisphere. We're still missing the north. And right now, no telescope in the northern hemisphere is being planned for the next few years. However, we might have another telescope in the south. As a matter of fact, it's being built right now. This is the Simons Observatory by the Simons Foundation that's most likely going to be replacing ACT in the next few years and will very likely start its mission in the next few years. Now the telescope is technically already operational, but not fully functional, and it even captured its first image in 2025 of this. Take a guess what this is. Yeah, this is Mars. This was obviously a demonstration, but in February of 2025, it achieved its first light. And so in the next 5 to 6 years, we might actually get another image that's even more accurate, that might be able to show us the cosmic microwave background in even more detail. But chances are, it's not going to be breaking any cosmological mysteries, mostly because the observations from this recent study definitively confirm a lot of models, and seem to also imply that our understanding of the early universe is extremely good. There doesn't seem to be anything wrong with modern predictions, and whatever is happening with the modern cosmology crisis seems to be the result of the universe in the last few billions of years. So I guess this is more of a recent crisis. And in this video, we're going to discuss some of the recent and, I guess, super unexpected results coming from a survey known as DESI, and in this case results that almost definitively suggest there is something wrong with modern cosmological models, and there is definitely something missing from the explanations in regards to how the universe is expanding. And in this case, even though the results are still not 5 sigma, or basically they're still not definitive, the level of significance here is high enough to actually raise a few eyebrows. And so let's talk about exactly what this new report is, what the new study discovers, and why this is, I guess, kind of important, at least when it comes to understanding the universe. But here, a really brief reminder. This is actually something that we've discussed before, specifically less than 1 year ago, because a similar report was released last year, but based on a much more limited data. You can discover more in the video in the description, but in essence, in 2024, there was already a bit of a hint that something here is basically not adding up. DESI, or Dark Energy Spectroscopic Instrument, by observing 450,000 quasars, discovered that the dark energy behaved in a way that was not predicted. And to be more exact, it basically discovered that the so-called cosmological constant was potentially maybe not so constant, which was very unexpected and obviously created a bit of a problem for modern cosmology. And because of these grandiose first discoveries, DESI continued observations and continued its primary mission, trying to figure out exactly what dark energy is and trying to figure out how the universe is expanding, which is precisely what it's been doing for the past year. And it was able to collect data about way more galaxies, from a lot of different distances, from a lot of locations in the universe, which allowed the scientists to create this beautiful three-dimensional map. And so in this case, these latest results represent approximately 3 years of collected data and contain roughly around 15 million quasars and different galaxies, or approximately 30 times more than last year. And this shows us roughly around 17 billion years of history, so basically not from the beginning of the universe, just the more recent times, in essence discovering the exact distance and the exact speed for each of the galaxies it was measuring. And so here, by knowing the exact distance and the exact speed, which is achieved using spectroscopy, we can then figure out how fast the universe seems to be expanding in every direction, and thus make some conclusions about the expansion of the universe, and even figure out how the universe might end. We'll come back to that point in a few minutes. And basically here, everything is about this cosmological constant, also known as lambda, also known as Einstein's constant. You can learn more about this in some of the links in the description, but in essence, for many years now, this was always believed to be the main explanation for why the universe is expanding and actually is accelerating its expansion as well. It was essentially believed to be this constant, lambda, in the Einstein's field equation. So essentially something that seems to be the part of the universe, or some kind of a fundamental constant that causes the universe to expand. There were obviously some other explanations, but most cosmologists and most physicists always explain this basically as a kind of a fundamental constant, something that's already in the universe, and something that could be related to quantum effects and the idea behind vacuum energy. But the main point is that it was supposed to be constant, kind of like the speed of light, kind of like gravitational constant, except that in this case this was a repulsive form of gravity. But because in the last decade we've been discovering a lot of inconsistencies with this constant, with the biggest issue being known as the Hubble tension, the video in the description talks about this more, This is why DESI became a project, and why the main point here was to basically observe the universe and then through direct observations try to basically come up with some potential conclusions. And so one of the main results from this recent study actually focuses on something very intriguing: BAO, Baryon Acoustic Oscillations. Now, if you don't want to watch that previous video that explains it, let me briefly cover exactly what this is, because this is a super fascinating concept. And a concept that's sort of visualized right here with these enormous circles. Technically, I guess it's spheres. And these BAOs are technically actual structures. These are basically sound waves from the beginning of the universe. Here we have to imagine the universe in the first 379,000 years. Back then, the universe was essentially kind of like a super hot soup containing a lot of matter, but also containing photons that actually had a lot of trouble moving through. And that's because during this time, everything around them was essentially like this super hot plasma. This is when the universe was still super hot. And this lasted for the first 379,000 years. But then we reached the point known as the recombination. This is when the universe cooled down just enough for all of this hot soup to finally cool down, which led to the formation of the first gas in the universe. This was no longer ionized gas, it was no longer plasma, it was basically just pure hydrogen and helium. And at this point, light finally was able to move through and finally escaped, which we now detect as the famous cosmic microwave background. This is basically that escaped light from the early universe. But prior to its escape, when it was still inside the plasma, because the light here could not move much, it actually ended up pushing on everything, basically because photons also produce just a little bit of momentum. And because the universe was not perfect, and because it had certain overdensities, at some point a lot of these very tiny overdensities would actually become a source of something else. Because here we had a little bit more gravity, they would obviously attract more matter toward them, and since a lot of this matter was also pressured by a lot of this trapped light, trapped photons, all of this started to form a lot of pressure moving against gravity, eventually forming a really bizarre interplay. An interplay between gravity and the pressure, which basically produced these very strange sound waves, or these fluctuation waves that were moving everywhere across the universe as a result of photon pressure interacting with gravity. And these were very likely extremely powerful, because once again a lot of this light was just simply trapped and was constantly pushing on the gas. And so basically they formed these really large bubbles, growing larger and larger in size. But, based on modern theories, we know that at some point the light escaped. As I mentioned, this happened 379,000 years following the Big Bang. And so once this light escaped, all of these bubbles suddenly froze in place. They were already really large, and there was no longer any push from anything, which basically resulted in these really thick overdensities, spherical in shape, with a very specific size. Mostly because we know in this case, the light traveled for approximately 379,000 years, constantly pushing on the matter. And based on modern calculations, we know that these bubbles were very likely approximately 500,000 light-years in radius, or basically 1 million light-years in diameter. This was at the redshift of 1089, or basically when the universe produced its first light. And this is essentially what the scientists refer to as BAO, Baryon Acoustic Oscillations, or I guess in other words, matter sound waves. The sound waves, or the music, of the early universe. And the thing is, they would have stayed the same size, approximately 1 million light-years across, if it wasn't for the expansion of the universe. And so the modern models predict that as the universe started to expand, over the past 13.8 billion years, these bubbles grew so big that they're now supposed to be roughly around 500 million light-years across, or 500 times as big. And knowing this, we can essentially try to figure out how fast the universe has been expanding, and thus use these bubbles to calculate the cosmological constant. But I guess the question is, how exactly do you find these bubbles, and how do you measure them? Well, we actually had a previous hint about one of these bubbles in the video in the description, but in general, what these BAO bubbles represent is basically a kind of a foundation, or I guess a kind of a scaffold, for the formation of future galaxies and future galactic clusters, because in this case, along the edge of these bubbles, this is where we find most of the overdensities. And so we actually expect to find more galaxies and more mass inside of these spherical formations across the universe. And so far, all of the studies we've had seem to confirm this and seem to actually suggest these bubbles do indeed exist. And more importantly, they have become bigger over time. But the main question DESI and this recent study were basically trying to answer is, have they been growing as predicted, or have they been growing faster or maybe slower? Well, based on previous calculations from the last 2 decades, we have very specific expectations about their growth. As I mentioned before, their current size is expected to be exactly 490 million light-years. And this process would have created a very specific separation of matter with very specific overdensities every 500 million light-years. Unless, of course, some of these bubbles crisscross, in which case we should be seeing some bubbles in the middle of other bubbles, which is kind of what you see in this image. And in cosmology, this is referred to as the sound horizon, the concept that's often used to calculate the overall expansion of the universe. And though obviously we don't expect to find every galaxy along the edge, we actually do expect a significant preference for most of the galaxies to basically be separated by this bizarre sound horizon distance. The distance that should decrease as we look back in time and as we find much older galaxies. And so technically this is also used as a kind of a standard ruler when it comes to measuring distances. And so in this recent study, lots of different researchers from lots of different countries and different universities essentially compiled the biggest analysis to date using approximately 15 million different galaxies and different quasars, with the main point being exact measurements of these bubbles across large parts of the universe. While also obviously comparing this to some of the previous discoveries from previous studies in order to find out what's actually happening. And this was then also combined with the data on Type 1a supernova in order to make the results just a little bit more accurate. You can find all of these studies in the description below. And one of the first main discoveries in this case was that a lot of data seems to agree with many observations from other telescopes, which of course suggests that the main picture, or I guess the main assumption about bubble and overall universe expansion, seems to be kind of correct. But there was a big problem. And this problem seems to appear as you try to go back in time and as you start comparing this data with some of the similar predictions using cosmic microwave background or that earliest light. And so when comparing this to the CMB observations and predictions about bubble, there is actually a noticeable difference. The circles in this case don't match. Or at least don't match if you assume that constant to be constant, with the measurements of the observed tension having significance of approximately 2.3 sigma at least, which in physics doesn't mean that it's certainly correct, but it does suggest that there is something going on and that we need more data. In this case, significance is higher than last year. And in essence, what this data basically tells us is that the DESI observations of these circles or these spheres suggest that there is a certain amount of stuff that seems to move at certain speed, but the calculations from CMB and from the earliest universe seems to suggest that there is actually different amount of stuff and it moves at different speed, which obviously makes absolutely no sense because we're looking at the same universe. And since before this was potentially explained as mistakes in observations or erroneous analysis, this excuse can no longer be used. Every single year we get a new study using different analysis and different observations, basically giving us exactly the same answer. The accelerated expansion of the universe seems to have changed over time, suggesting there is actually no cosmological constant, or that it's not a constant, or at least suggesting that this mysterious dark energy seems to behave differently. And so here, in at least one recent study, Ryan Keeley and his team kind of tried to explain this, assuming that the constant and the dark energy evolved over time, with these evolving models or changing models for the cosmological constant, or technically I guess cosmological variable, suddenly fitting really well with the observed data. And so here, by combining the cosmological variable with observations of supernova and observations of baryon acoustic oscillations, we actually end up with a really high significance value of 4.2. Not 5 yet, but pretty close to it. In physics, the sigma or significance value of 5 usually means that something is almost certainly there. But obviously this is just an observation and it provides zero explanations. First of all, we obviously have no idea what dark energy even is, but here we now have a new problem. Dark energy seems to also change over time, which obviously means that either we have an entirely new fundamental force that technically nobody wants to deal with because it creates a lot of new problems, or, as this new study suggests, maybe the universe has more than 4 dimensions. In other words, it's almost certainly scientists are discovering completely new physics here, and currently there's really no explanation. Except for maybe 2 potential explanations we've discussed previously that you can actually learn about in some of the videos in the description. One of them is in regards to fluctuating form of energy known as quintessence that might explain the universe expanding over time differently, but the other one is even more exciting, the idea known as the timescape cosmology. Basically here, maybe there is no dark energy, and all of this is just a result of observations based on Einsteinian principles, where time just starts to act differently in certain locations in the universe. This one is actually my favorite right now because it does actually make some really cool propositions. Once again, the video in the description. But naturally, because this is such an exciting observation and such an exciting discovery, we're going to have a lot of new studies coming out about this, and there are going to be way more observations by different telescopes. And even DESI observations are going to be continuing because it's not actually finished yet. Here eventually we'll have 5 years of data, and right now this was based on just 3 years. And so we still have at least 2 more years before final data comes out and before researchers come up with some final conclusions. Well, the final question that I wanted to answer is, so what exactly does all of this mean? At least for the universe and for our future. Okay, not like your future and my future. The future of the universe, if you know what I mean. Well, in this case, if dark energy changes with time, and if the cosmological constant is actually a variable, one day the universe could actually stop expanding and eventually start collapsing. Which means that instead of continuously expanding and eventually ripping apart, the end of the universe might actually be what's known as a big crunch. Basically here, the ultimate fate of the universe is a kind of a recollapse, where everything once again becomes super hot and eventually maybe becomes some kind of a tiny point, potentially restarting the Big Bang once again. With this animation, I guess, kind of showing us what might happen, which of course would also suggest that maybe cyclical cosmology has a point after all. Maybe the Big Bang we have now is just one of many such events that happened in the past, and maybe there's going to be another one in the future. Not like near future, very, very, very far future, because it will actually take a very, very long time before the universe starts collapsing once again. Here we're talking about possibly trillions of years, but very likely much longer. And today, we're going to discuss some of the recent discoveries in regards to one of the biggest mysteries coming out of the James Webb Space Telescope. The mystery we've previously discussed in a lot of other videos, right there in the description, that currently scientists refer to as the little red dots. Bizarre, unexplained formations discovered by the James Webb and only visible to the James Webb, that, as the name implies, basically resemble tiny red dots. And ever since the first observations and since the first analysis, they basically became one of the main mysteries. Because obviously we have absolutely no idea what we're actually looking at. Okay, we have some ideas that we're going to be discussing today, but it's still not super clear. And we've actually discussed one of these objects extremely recently, because something strange was discovered inside of one that was previously never seen before. In this case, we're talking about a very specific type of emissions that should be technically impossible. Once again, the link for this should be in the description. But here's what we know about them so far and what science has discovered in the last couple of years. First of all, even though they do appear in a lot of different imagery from the James Webb, they were only officially reported and described in March of 2024, essentially making them a new type of an object that was never before seen anywhere. And one of the main reasons they were so mysterious is of course because only the James Webb Space Telescope seemed to be able to see them. In other words, they were only visible to very powerful infrared telescopes. And what's really surprising here is that they seem to have very flat infrared spectrum. Or basically their infrared emissions were somewhat similar to each other and did not exhibit a lot of flares or a lot of variability. Moreover, there was no detection of X-rays or any other powerful radiation, and most importantly, there were no flares of any sorts. Which is of course what we usually expect from a typical supermassive black hole or from a typical AGN, active galactic nucleus. And so these were literally like tiny red lights everywhere that didn't seem to change much and seemed to produce the same color. Moreover, they all seem to exist around the same period of time. So far, all of them have been detected between 0.6 to 1.6 billion years after the Big Bang, with the youngest ones existing 12.2 billion years ago. But the majority seem to be visible about 600 million years following the Big Bang, and their numbers seem to disappear over time. Now, as far as I know, as of 2025, approximately 340 such objects have been officially confirmed, but there are probably a lot more hiding in the data. But because some of the initial observations did not reveal anything specific about these objects, this lack of data basically made it impossible to try to understand what we're looking at. So are these just tiny galaxies, bizarre black holes, compact collections of stars, or some strange energy we've never seen before? Or is this something unique to the early universe that just cannot exist anymore for some unknown reasons? But the first clues started to come out just based on the observations of the color, because they're all red And here we're talking about a very specific red. This basically implied a lot of gas and dust surrounding something very powerful and something very massive. We actually see something very similar in a lot of different dust-obscured galaxies, especially galaxies referred to as hot dogs, hot dust-obscured galaxies, but usually not to the same extent and definitely not as bright, with some of the first pieces of evidence suggesting that this is something that contains a lot of dust. But some of the recent observations started to reveal something else that's very important. This obviously contained a lot of hydrogen gas, but here the observations revealed that the Balmer lines, or the lines produced by emission of hydrogen, were not sharp and thin as you see them right here, but were instead much wider, or basically contained very broad Balmer emission lines. Now, not all objects contain this, but at least 80% did. And this was a telltale sign that there is a lot of extremely fast-moving hydrogen that seemed to be circulating something in the center. And here, based on the thickness of this emission line, it became possible to calculate the average speed. Basically, this is actually showing us the redshift and the blue shift of the line, with the implication being that this gas orbits around something central at over 1000 kilometers per second, which really only had one explanation: a supermassive black hole. And this was a telltale sign that whatever is happening here seems to involve black hole accretion. And moreover, because things were spinning so fast, it very likely involved a black hole that was also spinning fast and was very likely growing extremely rapidly. But if these were black holes, there was still basically this unanswered question: how come we don't actually see any flares? How come there are no X-ray emissions? And why is the infrared spectrum so flat and doesn't change in brightness at all? None of this is actually expected of an active black hole, and in most cases all other black holes are usually extremely unpredictable and produce tons of different emissions. Moreover, why do we only see these objects so far away? And why is it that nothing like this is seen closer to us? Or at least these were questions and assumptions from a few months back based on some of the previous observations. Actually, here the observations also suggested that these are really compact objects, potentially 2% the radius of the Milky Way, or basically no larger than 500 light-years across, but also objects that potentially contain ultramassive black holes, possibly hundreds of millions or even billions of solar masses in mass already. And that, of course, created a new problem. How is that even possible if the universe just began? We don't expect black holes to grow so fast, so quickly, following the Big Bang. So basically here we had some solutions, but also new problems. And well, when it comes to trying to answer the question of why we don't see these objects much closer to us, we potentially have an answer from something that was discovered not so long ago. And well, here we're talking about the objects you see right here. These were discovered by citizen scientists, and these are known as green peas. Very bizarre, very unusual objects, but this time instead of being red, they're actually green in color, but do possess extremely similar properties and seem to exist much closer to us. And once again, the video in the description talks about this discovery more as well. And so in essence, it's quite likely that green peas and little red dots are very likely related. Or basically, the black hole that seems to contain a lot of gas and a lot of dust eventually becomes slightly bluer as a lot of this gas and dust disappears over time, with some of these transition stages being visible as these green pea galaxies. But in this recent study, we potentially have some additional answers that actually finally explain some of the other unusual discrepancies, such as how these black holes can be so massive and why we don't actually see a lot of variation in terms of infrared emissions, or basically any other emissions either. With the explanation in this case once again focusing on one specific little red dot, with this one existing when the universe was about 660 million years old. And well, in essence, this study essentially confirms that these are indeed super unique objects and definitely nothing like we've ever imagined, and technically qualify as their own objects and not just active galactic nuclei. With the overall explanation from the study suggesting that these are indeed massive black holes, but in this case inside extremely dense cocoons of gas that in terms of density is actually super similar to the upper atmosphere of a typical star. And the best way to imagine this is to basically literally imagine a red giant star, such as for example Betelgeuse, but in this case a star with a radius of about 40 astronomical units, but in the center of this object there is a really massive black hole that's actively feeding and is also releasing huge amounts of energy from its accretion disk, which illuminates all of the gas around it and makes all of this gas and dust glow extremely brightly. So here we're basically seeing all of this gas and all of this dust glow as a result of the central black hole emitting huge amounts of energy. And so in essence, these might be supermassive black holes surrounded by very dense gas, potentially representing progenitors of some of the earliest galaxies, and related to a process that seemed to be very common in the early universe. But definitely not something anyone expected or anyone predicted, because a lot of different models and computer simulations never actually created anything like this, or even anything remotely similar to this, implying that there is something we're missing from the galactic evolutionary models. And so our assumption that we understand what the early galaxies might have been like is obviously incorrect. And so basically this seems to be a really large ball of gas, as you can see from this image, that seems to surround a super powerful accretion disk with a very powerful black hole voraciously eating a lot of matter, very likely at its limit. We usually call this the Eddington limit, with the black hole itself containing a very hot and a very powerful disk that's responsible for all of this brightness and all of this energy. But I guess even more intriguingly, this is just a small part of the actual galaxy itself. And so even though from our point of view this resembles a little red dot, there seems to be an actual galaxy around it that's just invisible as a result of this super bright object. And so the researchers in this study now refer to this as the black hole star, and the radiation from this black hole star seems to dominate all of the other light coming from the galaxy, basically making everything else completely invisible, even though it's very likely there. But there's one more important discovery in this study that clarifies some of the previous confusion. In previous studies, this was assumed to be an overmassive black hole, possibly up to 1 billion solar masses in mass. This doesn't seem to be the case. These new calculations suggest that this is possibly 100,000 to maybe 10 million solar masses maximum, or essentially at least 100 times less massive than previously assumed. And that is actually great news, because it doesn't mean that we need any special explanations for how these black holes are even possible, because black holes of that mass are technically predicted to exist in modern cosmology. Moreover, this seems to represent a population of rapidly growing black holes, and black holes growing ridiculously fast, potentially answering how supermassive black holes manage to get so big in certain galaxies. But the main reason we don't see anything else here, and the main reason there are no X-rays and no variations of light, is really because of this super dense cocoon of gas. It seems to dominate the optical spectrum, and it basically seems to be this super bright glowing gas resembling a massive star that's very likely brighter and more powerful than anything else at that period of time. And so basically, because it's so bright and so ridiculously powerful, it seems to suppress everything else. And right now this is the preferred explanation based on a lot of different studies, but it's not the only explanation, and there are obviously some alternative propositions. For example, this could still be a black hole ripping apart huge amounts of stars, basically causing an extremely massive tidal disruption event that was potentially only possible in the early universe. And because here some of the observations do actually resemble a tidal disruption event, technically this is still a possibility. Alternatively, this could also be a collection of extremely bright, very massive stars, or basically represent 10 billion solar masses of stars in a very small area all around each other, possibly serving as a precursor for some of the globular clusters or centers of various galaxies. But here it's not clear why these stars are basically not colliding and destroying each other, or why it's even possible, with scientists now believing that if we ever find additional calcium lines or calcium emission lines here, this might imply that this is indeed stars and not black holes after all. But right now, because these observations have not actually discovered anything like this yet, and because we only see hydrogen, the star explanation does not really make sense. And so I guess in conclusion, we seem to have discovered a completely new object. A massive black hole surrounded by a super thick cocoon of gas, making the whole object resemble a massive, enormous star. A star so bright, you can actually see it from approximately 30 billion light years away from planet Earth. And a star that seems to resemble an enormous giant Betelgeuse. And because they seem to be in many locations everywhere, this was potentially an extremely common phenomenon. But most importantly, because these recent explanations don't break any major rules and do not require any additional physics trying to explain anything else, currently this is actually the best possible explanation. But naturally, in the next few months, we might have to come back and discuss this more, assuming there are additional discoveries or something else is found that seems to challenge these propositions. And time to talk about unusual FRB signals once again. because it looks like we've discovered another one that seems to be extremely difficult to explain. Or essentially, another unusual radio signal coming from really far away, that though quite certainly is not coming from some kind of an alien civilization, and is quite certainly natural in its origin, currently has absolutely no explanation. And also seems to be coming from some mysterious source. And so let's discuss this in more detail, starting with like a 1-minute summary of what we know so far about these bizarre signals. The signals that actually happen several times per day, with potentially thousands of signals visible from the night skies within a 24-hour period, but only discovered in 2007, and that's because every single one of these signals is super short. Here's actually one detected from our galaxy a few years back, and it's extremely easy to miss this. They only last for a few milliseconds, but in that super short period of time, they're able to produce more energy than our sun does in approximately 1 year. And because so much energy is emitted in just a fraction of a second, this is one of the main reasons why they're so mysterious. But as you might have learned from one of the previous videos in the description, the biggest culprit right now is very likely some kind of a magnetar. A young and highly magnetized neutron star whose origin is technically also a bit of a mystery. But in a lot of different studies, more and more evidence seems to suggest that magnetars represent the best possible explanation. It's actually not entirely clear what exactly happens on these magnetars to cause these emissions, but as you might have learned from one of the previous videos, one explanation is some kind of a collision on the surface of a magnetar, or maybe a transition inside magnetar from, for example, neutrons to an ocean made entirely out of strange quarks. In other words, we don't know. But because many of these signals seem to come from some kind of a really small point, no more than 20 kilometers across, and also extremely magnetized point, magnetars are still the best explanation. For example, we know that in the Milky Way galaxy, this location is known for a magnetar as well. But when it comes to FRBs, there's actually a bit of a distinction between them. Some of them only happen once. Other ones seem to repeat. And it's the repeating FRBs that seem to present us with the best chance to explain what's going on. Mostly because by detecting exactly where they're coming from, we can then pinpoint the exact location in the galaxy where they're coming from, and then use statistical analysis to determine what's most likely to exist there and what can actually produce these signals. So for example, if they're coming from the center of the galaxy, maybe this is all a result of a supermassive black hole. If this is coming from some kind of a molecular cloud, or maybe a galactic arm, where we expect a lot of star activity and a lot of supernova, this could be a magnetar for sure, or at least some kind of a magnetized neutron star. But if they're coming from some kind of an ancient galaxy that doesn't actually have a lot of star activity, or maybe even coming from outside of the galaxy, now that's a different question, because in that case we don't really have a good explanation. And though in the past most of the FRBs have actually been traced to a lot of regions where we expect star activity, and thus magnetars were still the best explanation, in the last video you can find in the description, we actually discussed the detection from the galactic halo, or basically from a region where we don't really expect anything, except for maybe a few old stars. But this new detection is even stranger. It's actually coming from a study right here from 2023, where 25 repeating FRBs were discovered by the Canadian telescope known as CHIME, or KIME. Even after all these years, I still have no idea how to pronounce it. And while one of these FRBs detected in 2019, a repeating FRB was actually traced to a somewhat empty spot, or essentially was traced to somewhere where initial observations discovered absolutely nothing, which was a pretty big problem because here we really don't expect any magnetars or actually any activity whatsoever. And moreover, it was also super far away, and even right now it's one of the farthest FRBs ever discovered. It traveled to planet Earth for approximately 7 billion years, so it came from a redshift of 1. So there was always a bit of an uncertainty in terms of its exact location. But because it came from such a faraway distance, it did actually take a while to figure out exactly from where. But because this was a repeated FRB, over the years scientists improved the accuracy of the location, confirming that it indeed seems to be completely empty space, which obviously did not make a lot of sense. And so for several years now, researchers were trying to figure out what's actually happening with this FRB, and if this is some kind of an anomaly or something really bizarre and something really unusual. Well, it turns out that it is bizarre, but it did not come from nowhere. Because the study by Dante Hewitt and the international team right here finally discovered that it did come from a galaxy, an extremely dim galaxy, super far away. And a galaxy that was invisible for one simple reason. it's a very small dwarf galaxy that doesn't actually seem to contain much inside. But here's exactly how all of this was achieved, and of course what this means. First, scientists wanted to confirm the radiolocation. And so here they observed the burst for approximately 66 hours, catching it twice in the process. And once they knew where the radiolocation was, they used one of the most powerful optical telescopes, the Grand Telescopio Canarias, in order to conduct an extremely deep sky observation, just to see if maybe there is something here after all. And though at first there was indeed nothing, eventually they saw an extremely small patch. The patch visible right there inside the green arrow. And here this seems to represent the smallest galaxy in the area, which is also probably one of the farthest dwarf galaxies we've ever seen. And so this FRB also definitely came from inside the galaxy as well. But there's obviously one major problem. Finding a magnetar in a dwarf galaxy that's so dim is actually kind of unusual. And that's because most magnetars, and of course most FRBs, have usually been traced back to somewhat active massive galaxies. Yet in this case, this galaxy seems to be the least massive and the most dim discovered so far to produce some kind of an FRB. Although here there's also a side note. So as I mentioned previously, some FRBs only happen once, other ones seem to repeat. And turns out that repeated FRBs, for some reason, have been traced to dwarf galaxies in the past as well. As a matter of fact, for some reason, more repeating FRBs come from dwarf galaxies compared to non-repeating FRBs, which potentially suggests that maybe something inside these dwarf galaxies seems to encourage these repeated FRBs compared to non-repeated ones. And well, here one of the main explanations can actually be possibly seen near us, near the Milky Way. Because some dwarf galaxies, like the Large Magellanic Cloud, are known to contain a lot of supermassive stars. As a matter of fact, the most massive star we've ever seen is inside Large Magellanic Cloud. On top of this, some of the other records, including the star largest by size, was also in the Large Magellanic Cloud until relatively recently. And that star we've discussed recently because it might go supernova relatively soon. The video about this should be in the description. But basically, because we know Large Magellanic Cloud contains a lot of massive stars, and many of them do create very powerful supernova, there is maybe a chance that they also produce slightly different magnetars, which then end up producing repeated FRBs. In other words, even though this galaxy is approximately 100 times dimmer than most other galaxies responsible for FRBs, it doesn't mean that it's inactive. Actually, it can be super active, especially if it experienced a lot of collisions or some kind of a tidal disruption, which is actually what happened to the Large Magellanic Cloud. It was tidally disrupted by the Milky Way. And so the overall result from the study suggests that dwarf galaxies might actually be conducive to the production of fast radio bursts, at least the ones that are more active and produce a lot of signals. But it also suggests that some of the other detections, where researchers could not identify the exact galaxy, might have also actually come from barely visible dwarf galaxies that could be detected if we used a more powerful telescope. And so the study basically links these repeated FRBs to remnants from extremely massive stars. And more importantly suggests that we definitely have to do an optical telescope follow-up where the exact source or the exact galaxy could not be seen at first. We basically just need a bigger telescope. But at least for now, this is still just a hypothesis, and there is no exact explanation that applies to all FRBs, or explanation that seems to basically satisfy everyone. For all we know, these signals are caused by something entirely different depending on the galaxy, and for all we know, maybe this is actually an entirely different phenomenon that we just don't have an explanation for yet. And today, we're going to explore the idea behind the spinning universe, or basically try to tackle the question, is the universe spinning or is it just expanding in a single direction? Something that was recently investigated in this study by, alright, here we go, time to butcher some names, Balazs, Andriy, Zigeti, Istvan Zaputi, and some other difficult to pronounce people that actually did create a model that discovers something somewhat intriguing. But before we discuss the study, let's briefly discuss some of the previous propositions and also talk about why the majority of scientists today do not believe the universe is actually spinning. And I guess let's start with the facts first. We almost certainly know the universe is expanding, and it's also accelerating its expansion as you go farther and farther away. Today it's still unknown why, but the observational evidence is definitely there. Likewise, we also know that individual objects in the universe love spinning. Stars, planets, clusters, galaxies, and even galactic clusters seem to rotate, sometimes even at their limit. Which obviously leads us to the next question. So what about the entire universe? is there any chance that the entire universe is spinning as well? And this question has been recently addressed in one of the studies we discussed in the description, where based on observational evidence of a lot of different galaxies out there, surprisingly it was discovered that quite a few galaxies seem to spin in the same direction. And in that particular study, the conclusion was that basically, maybe this is because the universe is also spinning, and so as a result, it forces many galaxies to assume the same rotation as well. Although this is not a widely accepted proposition, and a more likely explanation is that many of these galaxies are just connected with the cosmic web, which generally does have a somewhat similar angular momentum, producing the same rotation. But at the moment we're just going to leave that as a mystery. Intriguingly though, this particular study became a bit controversial because the overall conclusion here was that since the universe could be spinning, we might be living inside some kind of a massive black hole. And while technically the observational evidence does not support that either. In other words, we're unlikely to be living inside a black hole, but at the moment this is still a bit of an open question. And the thing is, when it comes to this idea of the rotating universe, one of the first questions we should be asking is, so why would it be spinning to begin with? Because for example, for things like galaxies, stars, planets and so on, here rotation is the result of gravitational forces inside these systems. And so in order for the whole universe to spin, something else needs to be going on here, because the gravity would not be able to create this rotational force. And more importantly, if the universe was indeed spinning, we would actually have definitive signs based on a lot of observations in different frequencies. For example, light coming from opposite directions would actually look a little bit different. It might be just a little bit redshifted on one side and a little bit blue shifted on the other. Or at least if the universe was spinning fast enough. But based on the observations of the cosmic microwave background, and based on surveys of very distant galaxies, this doesn't really seem to be the case. So far, most of the galactic surveys and most of the surveys involving distant universe seem to show the universe as relatively similar in every direction. With the overall conclusion being made a few years back, being that if the universe is spinning, or if it's rotating, it cannot be doing so faster than about 1/1000th of a degree every billion years. So basically here the rotation would be barely perceivable. Although here I do have to mention something that was bugging astronomers and cosmologists approximately 10 years ago. The so-called cosmological axis of evil. And this was based on some of the earlier observations of the cosmic microwave background that revealed a potential presence of a kind of an axis that would maybe imply some kind of a rotation. Basically here there was a somewhat unexpected alignment, suggesting a kind of a preferred direction that the universe seemed to possess. And this was definitely unexpected and in opposition to the modern cosmological principles, because the universe should be same in all directions. It should be isotropic. And while it wasn't until 2016 that it eventually became not really a problem. With much more accurate observations from ESA's Planck telescope, researchers confirmed that this was some kind of a bias and was not actually there at all. The universe indeed seemed to be isotopic and pretty much similar in every direction. Or basically, the axis of evil was just a result of poor data. And so unlike previous observations that the top half of the CMB was just a little bit colder, here these new observations suggested that this was not the case. And so basically most of the modern observations do actually provide evidence for the non-rotating universe and no axis of any kind, and the universe being the same in every direction, just as predicted by the Big Bang theory. However, here it's also important to mention another intriguing model. A model proposed as a kind of a thought experiment to disprove some of the Einsteinian principles, and was proposed by this person, Kurt Gödel, a major 20th century influencer in scientific and philosophical thinking, who basically proposed a lot of different ideas and a lot of different models, mostly in the field of logic. And in 1949 he proposed something to basically question Einsteinian theories, the idea of the rotating universe and what this might produce. And his main point was to prove that general relativity proposed by Einstein was incomplete. Here he used the example of rotating universe that contained only one ingredient, a kind of a negative cosmological constant that would prevent the universe from expanding, making it constant. This, by the way, was before the idea of expansion and before the Big Bang theory. And so here, in a spinning universe, we would have these centrifugal forces that would technically cause the expansion. But living in such universe would be super strange. Mostly because here, you actually suddenly had the idea of time travel, as long as you start traveling somewhere far away. Now, first of all, for every single observer in every single location, the universe would appear to be spinning, and you would appear to be in the center of the spin. Or basically, you, as the observer, would be the axis. And though back then this actually appeared to be strange, today this is exactly how we explain the expansion of the universe as well. The universe appears to be expanding in every direction from every single point in the universe. But things do get a bit stranger once you start traveling far away, because here any information and any light will actually start curving as it moves around this rotating universe. Or essentially, even though things are traveling straight, because they're inside the spinning object, their movement will start curving. And at some point, at a very far away location, anything that's traveling straight will actually curve so much that it's now traveling back, eventually coming back to where it all started. But this is where things get just a little bit strange. Anything that comes back from this unusual journey actually finds itself back in time, or basically arrives to the location where it has not left yet. So yeah, it traveled back in time. And to Gödel, this presented a major logical problem. This basically created a time paradox and violated notions of causality. He actually used the example of a rocket traveling really fast, really far, and basically coming back in time before it even left. And to Gödel, this was the reason he believed general relativity was incomplete and didn't really make a lot of sense. Mostly because here it created this time travel paradox. Luckily for Einstein, and luckily I guess for us, all of the evidence points at two things. First, Einstein seems to be correct with most of the predictions when it comes to relativity, and second, there is no evidence that the universe seems to be spinning at all. In other words, even though Gödel's model is correct in terms of thought experiments, this doesn't seem to apply to our universe. If you want to read more about this, by the way, it's known as the Gödel metric, and the link for this is in the description. But now we have this new study that once again focuses on a kind of a reworked version of the Gödel ideas and tries to actually solve one of the biggest mysteries in cosmology. This is essentially the title of the study: Can rotation solve the Hubble puzzle? And the puzzle is of course the famous Hubble tension, which is now technically referred to as the Hubble crisis. The now basically undisputed evidence that not only is the universe expanding and is also accelerating its expansion, it seems to have changed the acceleration over time, or to rephrase this, the idea known as the dark energy that's supposedly accelerating everything and is potentially connected to the famous cosmological constant, seems to have changed over time, and the cosmological constant may not be a constant. Currently this has no explanation, or at least explanation based on any specific evidence, but in this study the proposition is that, technically, things do make a little bit more sense if the universe is spinning just a little bit. So basically here, by developing a kind of a Gödel-based spinning model, the team showed that if we apply the same rules to the modern universe, but also add just a little bit of rotation into the mix, the model seems to resolve this Hubble tension without contradicting any current cosmological measurements, while also being compliant to the idea of rotating universe, but because it's spinning so slow, it's barely visible and also doesn't actually create any time paradoxes because the rotational curve is not big enough. With the suggestion being that the universe could be rotating once every 500 billion years, which would actually make it way too slow to detect easily, but would provide enough, I guess, centrifugal force to create this Hubble tension, or the change in acceleration of the universe. And so here one advantage is that this kind of avoids these time travel paradoxes and is also kind of compliant to previous non-detections of the rotation of the universe, while also connecting some of the previous studies, including the one where so many galaxies were shown to spin in a very similar way, independent of the distance. In other words, there might be something to that spinning universe proposition after all. But this obviously doesn't prove that we live inside a black hole, and more importantly, there is absolutely no evidence for any of this. It is basically just a mathematical model, and that's actually really the catch here. Because the rotation here is so slow, it is actually below our current detection capability. Even with most powerful telescopes, we would not be able to detect any of these curves or find any evidence that the universe is spinning so slow. And so the obvious question is, okay, so how do you prove this then? Well, the best next step would be to create some kind of a computational model, and specifically a supercomputer simulation, where this evolving universe is simulated by adding just a little bit of a spin, and then essentially seeing what we discover and comparing this to the actual observations. If these future computer simulations discover that it seems to actually create something more realistic, this would give this proposition a lot more credibility. But for now, based on what we have so far, this is yet another cool explanation, but without evidence and without actual proof, it's impossible to know if this is correct. Nevertheless, based on some of the future observations and future surveys, specifically some of the new releases from DESI and even from the James Webb, we might get some clues answering the question of is the universe spinning or not. Right now though, based on the observations from the cosmic microwave background, the answer seems to be no. But if this rotation is nearly imperceptible, it would probably not show up in the CMB either. And so until we have some future observations and more evidence, that's pretty much all I wanted to mention. Check out some of the previous videos in the description. Thank you for watching, subscribe, share this with someone who loves to learn about science, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.